So welcome students. In this video, let us look at the introduction of the topic trigonometric equations, and we'll see what the meaning of trigonometric equation is, what the meaning of solution of the trigonometric equation is, the meaning of general and principal solutions of a trigonometric equation. First, an equation involving one or more trigonometric functions of an unknown angle is called a trigonometric equation. So, a trigonometric equation, for example, can look like tan square theta is equal to 2. So, this is a equation involving a trigonometric ratio of an unknown angle. So, the trigonometric equation can look like the secant square theta minus 5 secant theta plus 6 is equal to 0. This is a trigonometric equation involving the trigonometric function secant. So you can also have a trigonometric equation in more than one trigonometric functions. For example, sin x plus cos x is equal to 1. This is a trigonometric equation in two trigonometric functions. So now, once the trigonometric equation is given, you'll be asked to solve this trigonometric equation. So what is the meaning of solving of this trigonometric equation? That means you need to find the solution of this trigonometric equation. So the solution of trigonometric equation is nothing but the values of theta for which this equation is valid. The values of the unknown angle. So it might be theta in some case, x in some case, y in some equation, so on, whatever it is, the values of unknown angle for which the equation holds is called the solution of the trigonometric equation. But there is a slight difference between the normal equations that we have encountered till now, which are called algebraic equations, and trigonometric equations. So first let us see the difference between algebraic equations and trigonometric equations. So for example, let us take a very simple algebraic equation, which is x square is equal to 1. It's a very simple quadratic equation. So what are the solutions of this? What are the solutions of this algebraic equation? That means, what are the values of x for which this equation holds? Obviously, x square is equal to 1 implies x is equal to plus or minus 1. There are two solutions. So let us take the corresponding trigonometric equation. Something like sin square x is equal to 1. So how many solutions does this equation have? Sin square x is equal to 1 implies sin x is equal to either plus 1 or minus 1. So now comes the difference between algebraic part and trigonometric part. We know that trigonometric equations are periodic functions. That means their values repeat after a certain interval. That is, if sin x has to be equal to 1 for the position which is of 90 degrees corresponding to the ray of this position, the value of sin x will always be equal to plus 1, and correspond to this position of minus 90 degrees, the value of sin x is always equal to minus 1. That means if sin x has to be equal to plus 1, x can be equal to 90 degrees or 1 rotation plus 90 degrees, that is 360 plus 90, 360 degrees plus 90 degrees, or 2 rotations plus 90 degrees, that is 720 degrees plus 90 degrees, so on, 3 rotations plus 90 degrees, 4 rotations plus 90 degrees, as long as the ray stops, at this position, the value of sin x will be equal to plus 1. Now, for what values of x will sin x be equal to minus 1? So sin x will be equal to minus 1 for this position, right? So x can be equal to minus 90 degrees or 1 rotation and then minus 90 degrees, that is 360 degrees minus 90 degrees, 2 rotations minus 90 degrees, 720 degrees minus 90 degrees, so on. So these are the values of x which are possible. So do you see the difference between algebraic equation and trigonometric equation? Algebraic equation usually have finite number of solutions, usually. and trigonometric equations usually have infinite number of solutions. So you need to have a way to represent all these solutions. So if sine square x is equal to 1, the solution of this equation is not one particular number or two particular numbers. So you have infinite number of solutions. So what we are going to learn is a way in which you can express all these solutions in a single line. So as you can see here, so is there an easy way to represent all these solutions? So let me write in radian form. So the answers are pi by 2, 2 pi plus pi by 2, 4 pi plus pi by 2, so on. 2 pi plus pi by 2, 4 pi plus pi by 2, so on. This is one set of solutions. Or you can also have minus pi by 2, 2 pi minus pi by 2, 4 pi minus pi by 2, so on. So is there some way in which you can express all these solutions? So can you express all these solutions in the form of 2n pi plus or minus pi by 2, where n belongs to integers, because this can go in the negative direction also. Minus 2 pi plus pi by 2 is also valid. Minus 4 pi plus pi by 2 is also valid. So there is some way in which you can express all the solutions in terms of a variable number which belongs to integers. So this way of writing the solution is called the general solution of trigonometric equation. The general solution of sine square x is equal to 1 can be written as 2n pi plus or minus pi by 2, where n belongs to integers. And this solution covers all the possible solutions for this equation sine square x is equal to 1. And that brings us to our next topic, the difference between general solution and principal solution. So we have already seen what a general solution is. It is, for example, so if you have the equation sine square x is equal to 1, this equation will be satisfied for infinite values of x, and there is a way to express all those infinite values in a simple expression. So x is equal to 2n pi plus or minus pi by 2, where n belongs to z. That means if you put different integers in the place of n, you go on getting different values of x, and each of the value is a solution to this equation, and all the solutions of this equation can be expressed in this form. It works in both ways. So this has to express all the solutions, and all the solutions have to be of this form. So this is called the general solution of the equation sine square x is equal to 1. What is principal solution? Principal solution are the values of those x's which satisfy this equation, which lies in the interval 0 to 2 pi open, close at 0 to open 2 pi. That means the solutions which lie in the first rotation are called the principal solutions. There is the first rotation, that is 0 to 2 pi, close 0 to open 2 pi, or 0 to 360 degrees. 0 included, 360 not included. The solutions which lie in this interval are called the principal solutions. So to get the principal solutions is very easy. That means you just write the general solution and see which of these solutions are in 0 to 2 pi. For example, if you take the solution, so for n is equal to 0, you have plus or minus pi by 2. For n is equal to 1, you have 2 pi plus or minus pi by 2. Next, for n is equal to 2, you have 4 pi plus or minus pi by 2. So on. For n is equal to minus 1, you have minus 2 pi plus or minus pi by 2. Minus 4 pi plus or minus pi by 2. So on. All these are solutions to this equation. Now you need to search for solutions which lie between 0 to 2 pi. So you can see that plus pi by 2 is in the first rotation 90 degrees. So pi by 2 is one of the principal solution. And 2 pi plus pi by 2 is more than 2 pi. I don't want that. 2 pi minus pi by 2, which is 3 pi by 2, is also in the first rotation. So pi by 2 and 3 pi by 2 are the principal solutions of this equation. So you can see that all the other solutions lie beyond 2 pi or before 0. Minus 2 pi plus pi by 2 is negative. Minus 2 pi minus pi by 2 is also negative. So there are only two solutions, pi by 2 and 3 pi by 2 in the first rotation, that is in between 0 and 2 pi or 0 and 360 degrees. So these two constitutes the principal solution of this equation. So I hope you understand the difference between the general solution and the principal solution. If you know the general solution, it is very straightforward to find the principal solution. You just need to search for those values of solution which lies in between close at 0 to open 2 pi. So let us look at some more examples. So if you have the trigonometric equation sin x is equal to 0, it's a very simple trigonometric equation. So I want the values of those angles for which sin is equal to 0. So if you draw the quadrant diagram for sin, so it looks like plus, plus, minus and minus. That is, the sin values are positive in the first two quadrants, negative in the next two quadrants. So for what positions of the ray will sin x be equal to 0? Sin x will be equal to 0 when x is equal to 0 or when x is equal to pi. At 0 as well as 180 degrees, at these two positions, the value of sin will be equal to 0. So if I write all the solutions, so you have 0, pi, and as you go on rotating, whenever the ray passes these two positions, you have a solution. So pi, again you have a 2 pi, you have a 3 pi, you have a 4 pi, so on. All these are solutions to sin x is equal to 0. This implies if I have to write this in a standard form, can you see that all these are multiples of pi? So sin x is equal to 0 implies x is equal to n times pi, where n belongs to integers. You can also go to minus pi, minus 2 pi, so on. So you have solutions on this side of 0, on this side of 0. So sin x is equal to 0 implies x is equal to n pi. This is something which I remember because it is so easy that I remember this result. Sin x is equal to 0 implies x is equal to n pi. And whenever I deal with problems, I'll write this directly. I don't need to derive this. Next. So if you're asked to find the principal solutions to this, the principal solutions are nothing but 0 and pi. You have two principal solutions for this. Next, you have cos x is equal to 0. So what are the solutions of cos x is equal to 0? So if you draw the quadrant diagram for cos is positive in the first and fourth quadrants, negative in the second and third quadrants. So cos x will be 0 at this position of the ray and this position of the ray. Cos 90 is 0 and cos 270 is 0. It starts with 1, it goes to 0, it goes to minus 1, it comes back to 0, it again goes to plus 1. So these are the two positions which we want. So what are the solutions for this? X is equal to pi by 2, and what this position is 3 pi by 2. And in the second rotation you have 5 pi by 2, the second rotation you have 7 pi by 2, so on. You can go to negative values also, minus pi by 2, minus 3 pi by 2, so on. So all these are solutions to the equation cos x is equal to 0. So is there a general way to write this? Yes. All these are nothing but odd multiples of pi by 2. So I can write x as odd number can be written as 2n plus 1 times pi by 2. So the general solution of cos x is equal to 0 is 2n plus 1 times pi by 2, and the principal solutions are nothing but 90 degrees and 270 degrees. Pi by 2 and 3 pi by 2 are the principal solutions. All these solutions constitute the general solution. Now let us take tan x is equal to 0. So if you have tan x is equal to 0, what is the solution of this? So again, what is the quadrant diagram for tan? Plus, minus, plus, minus. So where will tan be 0? If tan has to be 0, we know that tan is sine by cos. So if tan x is equal to 0 implies sine x is equal to 0. And the solution will be exactly same as the solution of sine x is equal to 0. Hence, the solution is x is equal to n pi, and the principal solutions are 0, So sin x is equal to 0, cos x, tan x. Similarly, if you have cot x is equal to 0, cot x is nothing but cos x by sin x. So if cot x has to be equal to 0, cos x has to be equal to 0. That means the solutions of these two equations are same. So x is equal to 2n plus 1 times pi by 2. And the principal solutions are pi by 2, comma 3 pi by 2. These are the principal solutions. Next, if you have the equation sin x is equal to 1, sin x is equal to 1, what is the solution for this? So if you draw the quadrant diagram for sine, you have plus, plus, minus, minus. So sin x is equal to 1. Where will sin x be equal to 1? Obviously at 90 degrees. So you won't have any allied position for 90 degrees, because 90 degrees, if you have any angle in the first quadrant, its reflection will be the allied position, but 90 does not have a reflection. So x is equal to 90 degrees. This position corresponds to sin x is equal to 1. This position corresponds to sin x is equal to minus 1. So I want sin x is equal to 1. So you have only one position for this. So you have x is equal to pi by 2, right? And 2 pi plus pi by 2. That is 5 pi by 2. Next, you have 4 pi plus pi by 2, right? 4 pi plus pi by 2. So in each rotation, you have only one solution for this. This is the speciality of sin x is equal to 1. So I can write x is equal to 2n pi plus pi by 2. That is pi by 2. If n is equal to 1, you have 2 pi plus pi by 2, 4 pi plus pi by 2, so on. Or I can also write it as 4n plus 1 times pi by 2. 4n plus 1 times pi by 2 if I take the LCM. So this is the general solution of sin x is equal to 1. And what is the principal solution of sin x is equal to 1? Principal solution is only pi by 2. You have only one of this. So next, let us look at cos x is equal to 1. So where will cos x be equal to 1? If you draw the quadrant diagram, plus, plus, minus, minus. So this is the position where cos x is equal to 1, cos 0 is equal to 1, and here it is minus 1. So you have only one position again. So 0, 2 pi, 4 pi, 6 pi, so on. So x is equal to 2n pi is the general solution for this. And what is the principal solution? So principal solution is just the angle 0. You won't have any other principal solution for this. So sin x is equal to 1, cos x is equal to 1 has only one principal solution. And the general solutions for sin x is equal to 1 is 4n plus 1 times pi by 2. Cos x is equal to 1 is 2n pi. So if you have the equation sin x is equal to minus 1. So what is the general solution for and principal solution for this? So if you draw the quadrant diagram for sin, plus, plus, minus, minus. So this will be the corresponding position of the ray where sin x is equal to minus 1. So you have only one position, which is 3 pi by 2, or I can write as minus pi by 2. So the solutions are minus pi by 2, 2 pi minus pi by 2, right? One complete rotation and then go to minus pi by 2. This 2 pi minus pi by 2, 2 rotations minus pi by 2, so on. Some number of complete rotations minus pi by 2 is the solution for this. So what is the general solution? 2n pi, this time minus pi by 2. That is nothing but 4n minus 1 times pi by 2. That means if you have 4n plus 1 times pi by 2, the value of sin x will be equal to plus 1. If you have 4n minus 1 times pi by 2, the value of sin x will be minus 1. And what is the principal solution? Principal solution is just one angle 3 pi by 2. This is the principal solution of sin x is equal to minus 1. Next, if you go for cos x is equal to minus 1, so the general solution comes from this position. So this is the 180 degrees is the position where cos x will be equal to minus 1. You have only one position. So what are the answers for this? X is equal to pi or 3 pi or 5 pi, so on. That's nothing but odd multiples of pi. So at even multiples of pi, cos x is equal to plus 1. At odd multiples of pi, cos x is equal to minus 1. And the principal solution is nothing but pi. We have only one principal solution. So I hope you have understood the difference between the general solution and the principal solution. So now we can move on to the next topic. So in this video, let us look at very simple trigonometric equations. So there are three types of simple trigonometric equations. So let us go for type 1. So type 1 trigonometric equations look like sine theta is equal to sine alpha, cos theta is equal to cos alpha, tan theta is equal to tan alpha, cosecant theta is equal to cosecant alpha, secant theta is equal to secant alpha, cot theta is equal to cot alpha. So if you have equations of this form, these are called simplest trigonometric equations of type 1. Okay. For example, so if you have a very simple trigonometric equation, sine theta is equal to half. So how do we solve this trigonometric equation? Sine theta is equal to half, and you know this number half occurs when theta is equal to 30 degrees in the first quadrant, right? Sine theta is equal to sine 30 degrees effectively. Usually you will be given a number. You need to search for this angle from your knowledge of basic trigonometry. So sine theta is equal to sine 30. How do we solve this? So if I write theta is equal to 30 degrees and come out, that will not be the right answer, because sine theta will be equal to half, not just for one value of theta. It will be equal to half for infinite number of values for theta. So you need to give all the values of theta if I ask you the solution. So to understand this, first I'll draw the quadrant diagram for sine theta. So quadrant diagram for sine theta means quadrant diagram where you write the signs of the trigonometric ratio sine. So the signs of sine are plus, plus, minus, minus, right? So sine is positive in the first two quadrants, negative in the second two quadrants. Now sine theta is equal to half. You get one angle as 30 degrees. So this is one position of the ray where sine theta will be equal to 30 degrees. Now from the concept of allied positions, so if the corresponding sign for this position is equal to half, the corresponding sign for this position is also equal to half the mirror image position or the allied position. So if this is 30, this is 30, that means this angle is 150 degrees. So for 30 degrees as well as 150 degrees, for this position as well as this position, sine will be equal to half. For the positions in the third quadrant and fourth quadrant, sine theta will be equal to minus half. I want sine theta is equal to plus half. So I'll take these two positions as my required positions. So within one complete rotation, sine theta becomes half at two different positions. So the answers are theta is equal to 30 degrees as well as 150 degrees. Is there a nice way to write this? Yes, this is pi minus 30 degrees. So it will be easier to write in radian measure. So 30 degrees. So theta is equal to pi by 6, 30 degrees, and pi minus pi by 6, right? Pi is 180 minus 30 degrees, pi minus pi by 6. These are the two solutions in the first rotation. And in each rotation, I'll be going on getting two solutions. So if I want to write the solution in the next rotation, so this is 2 pi plus pi by 6, right? 2 pi plus pi by 6, and 2 pi, 3 pi minus pi by 6, and 2 rotations plus pi by 6, that is 4 pi plus pi by 6, 2.5 rotations minus pi by 6, that is, right, 2.5 rotations minus pi by 6, 5 pi minus pi by 6, 3 rotations plus pi by 6, 6 pi plus pi by 6, 3.5 rotations minus pi by 6, 7 pi minus pi by 6, so on. So these solutions go on. So the set containing all these solutions is called the general solution of this equation. So I'm not trying to solve this example. I'm trying to find a general way in which you can write the solutions. So what I want you to see is the pattern in this solution. Pattern in these solutions. So do you see that there is a very nice pattern in this form of solutions? So pi by 6, 2 pi plus pi by 6, 4 pi plus pi by 6, 6 pi plus pi by 6. So if you have even number of pi's, you're getting plus. And if you have odd number of pi's, 1 pi minus pi by 6, 3 pi minus pi by 6, 5 pi minus pi by 6, 7 pi minus pi by 6. So if you have odd number of pi's, you're getting a minus. If you have even number of pi's, you get a plus, right? So is there some way in which I can write this in a single expression? So theta is equal to, what I write is n pi is not n pi plus or minus pi by 6, n pi plus minus 1 whole power n times pi by 6. So this minus 1 whole power n is a very tricky expression. This becomes plus 1 if n is even. So for all even numbers before pi, you're getting plus. So if n is even, minus 1 whole power n will be plus 1. So you get plus pi by 6. And if n is odd, minus 1 whole power n is minus 1. You get a minus here. So this is the general solution to the equation sin theta is equal to half. And if we extend the same logic to sin theta is equal to sin alpha, the solution for sin theta will be, sin theta is equal to sin alpha is n pi plus minus 1 whole power n times alpha. So here it is sin 30 degrees, so you got pi by 6. If this has been root 3 by 2, you get 60 degrees. So you have pi by 3 here. If this would have been 1 by root 2, you get 45 degrees here. You get a pi by 4 here. So n belongs to integers. So the general solution for sin theta is equal to sin alpha is nothing but n pi plus minus 1 whole power n into alpha. That's the pattern for sin theta is equal to sin alpha. And the same works for cosecant theta is equal to cosecant alpha, because the quadrant diagram for both these ratios looks same. But this solution does not work for this. Let us look at how things work for cos theta is equal to cos alpha. So now to analyze the solution for these type of equations, cos theta is equal to cos alpha, secant theta is equal to secant alpha, let us take an example again. So let us try to solve cos theta is equal to half. So let us try to solve cos theta is equal to half. What is the general solution for this equation? So now what we do is we'll search for this half. So for what value of theta in the first quadrant will cos be equal to half? So we have cos half. Half is nothing but cos of pi by 3, cos 60 degrees, right? So now let us draw the quadrant diagram for this. So what is the quadrant diagram for cos? Plus, minus, minus, plus. Cos is positive in the first and fourth quadrants and negative in these quadrants. Now corresponding to pi by 3, you're getting cos theta is equal to half. That means pi by 3 is one of the solution. So now what are the other positions of the ray where you get the same value half? So obviously if you get plus half for this position, you get plus half for this position also, which is the allied position. So which is minus pi by 3. So cos pi by 3 is also equal to half. Cos minus pi by 3 is also equal to half. Now these are the two positions which make cos theta is equal to half. So let me write the solutions. So the solutions are plus or minus pi by 3, right? And what are the other solutions? If I complete one rotation, 2 pi plus pi by 6 or minus pi by 6, right? So I can start with 0 and go for plus or minus pi by 6. After one rotation, plus or minus pi by 6, sorry, pi by 3. And after two rotations, plus or minus pi by 3. so on, plus or minus pi by 3, 2 pi plus or minus pi by 3, 4 pi plus or minus pi by 3, so on, right? So now, once you have these solutions, you need to think about a general way in which you can write these solutions. So this pattern goes, and you can also write minus 2 pi plus or minus pi by 3. So you can complete one rotation in the clockwise direction. Minus 2 pi plus pi by 3 minus pi by 3, right? So you can go on to the negative side also. So if you observe these solutions, is there a nice way to write these solutions? So I can see that whatever numbers occur with pi this time, all those are even numbers. Odd numbers are not even visible to me. So theta is equal to, can I write it as 2n pi? Even multiples of pi can be written as 2n pi. So I always have plus or minus pi by 3 for everything. So 2n pi plus or minus pi by 3. So cos theta is equal to half implies theta is equal to 2n pi plus or minus pi by 3. So this is the general solution to the equation of the form cos theta is equal to cos alpha. So instead of pi by 3, if you have alpha, so instead of pi by 3, you get alpha here. So what is the general solution for equations of this type? Cos theta is equal to cos alpha. Theta is equal to 2n pi plus or minus alpha. So you need to remember these expressions. Now let us go to the third equations. Tan theta is equal to tan alpha and cot theta is equal to cot alpha. So to understand these equations, let us take an example. Let us try to solve tan theta is equal to 1. Let's try to solve tan theta is equal to 1. So now we know that 1 can be written as tan of 45 degrees, that is pi by 4. So now let us draw the quadrant diagram for tan theta. So we know that tan is positive in the first and third quadrants and negative here. So now we know that tan theta is equal to 1. Theta is equal to pi by 4 is being satisfied. So corresponding to the position of the ray, which is pi by 4, this equation is getting satisfied. Now what are the allied positions of this ray which makes tan theta is equal to plus 1? Because tan is positive in the first and third quadrants, you need to go to this allied position, right? If you go to this allied position, you get tan theta is equal to minus 1. And in the fourth quadrant also tan theta is equal to minus 1. So these are the two positions of the rays which maintain tan theta is equal to plus 1. So how can I write these solutions? So first solution is pi by 4. The next solution is 180 plus pi by 4. Pi plus pi by 4. The next solution is 2 pi plus pi by 4. The next solution is 2 pi 3 pi plus pi by 4. So I hope you're able to see the pattern here. So pi by 4, pi plus pi by 4, 2 pi plus pi by 4, 3 pi plus pi by 4. You can also have negative values. Minus pi plus pi by 4, minus 2 pi plus pi by 4, so on. Minus pi plus pi by 4, minus 2 pi plus pi by 4, so on. All these are solutions to this equation. So is there a general way to express all these solutions? So I can write theta is equal to, so you can see all integer multiples of pi are being seen here. So you have n pi. This time you don't need even multiples, you need all multiples. And with each of them you just have plus pi by 4 here. So I can write the general solution of tan theta is equal to 1 as theta is equal to n pi plus pi by 4. And if you have pi by 4 here, pi by 4 appears here. So if you have another angle alpha here, that angle appears here. So tan theta is equal to tan alpha implies theta is equal to n pi plus alpha. So theta is equal to n pi plus alpha is the solution to the equations of this type. So sin theta is equal to sin alpha, cosecant theta is equal to cosecant alpha implies theta is equal to n pi plus minus 1 whole power n times alpha. For cos it is 2n pi plus or minus alpha. For tan it is n pi plus alpha. So these are the three things that you need to remember in type 1. So let us try to summarize this and take some examples. So to summarize this topic, So in simplest equations of type 1 have 3 subtypes. First type is sin theta is equal to sin alpha or cosecant theta is equal to cosecant alpha. If you have equations of this form, the solution for this equations look like theta is equal to n pi plus minus 1 whole power n into alpha, and that comes from this quadrant diagram. And the second equations of the form cos theta is equal to cos alpha and secant theta is equal to secant alpha. We'll have the quadrant diagram like this, and the values of general solution of theta is 2n pi plus or minus alpha. And for tan theta is equal to tan alpha and cot theta is equal to cot alpha, the solution is theta is equal to n pi plus alpha, and the quadrant diagram is plus minus plus minus. So it's always better to remember the quadrant diagram as well as the solution, because if you forget the solution from the quadrant diagram, you can get the solution itself. Let us look at this question. Find the principal and general solutions to these 4 equations. First equation is tan x is equal to root 3, secant x is equal to 2, cot x is equal to minus root 3, cosecant x is equal to minus 2. So we have already seen how to do these questions. Let us apply this process. So the first equation is tan x is equal to root 3. This is a very basic trigonometric equation. So if you have equation of this form, tan x is equal to some number, the first thing that you need to do is choose an angle. Choose a very basic angle whose tan is equal to root 3. So the quadrant diagram for tan is plus minus minus plus. So if you have tan x as a positive number, you always get some angle correspond to this number in the first quadrant, right? So root 3 corresponds to 60 degrees. So root 3 can be written as tan of 60 degrees. So tan x is equal to tan 60. So now that we have remembered the basic answers to these type of equations, you don't need to derive them again. So x is equal to, so obviously if this is a position which satisfies tan x is equal to root 3, correspondingly this allied position also satisfies this tan x is equal to root 3. So how do you express all the solutions? General solution is given by x is equal to n pi plus alpha. So tan x is equal to tan alpha implies x is equal to n pi plus alpha is pi by 3 in radians. So x is equal to n pi plus pi by 3 is the answer to this first question, right? So next, you're also asked to find the principal solutions. Principal solutions are those solutions which lie in the first rotation. So the principal solutions are nothing but set containing the first principal solution is pi by 3, which is 60 degrees, and the second principal solution is pi plus pi by 3, that is 4 pi by 3. So these two are the principal solutions of this equation, and this is the general solution where n belongs to integers. So now let us go to the next question. Secant x is equal to 2. So let's try to draw the quadrant diagram for this. The quadrant diagram looks like this. So secant is positive in the first and fourth quadrants, negative here and here. So secant x is equal to 2. You'll get some angle in the first quadrant such that secant x is equal to 2. So we know that secant x is equal to 2 implies cos x is half. Again, you have 60 degrees. So the basic angle is again 60 degrees, which is pi by 3. That means secant x is equal to 2, and 2 can be written as secant of pi by 3. So now these are the form secant x is equal to secant alpha. So what is the general solution? X is equal to, correspond to cos and secant, it is 2n pi plus or minus alpha. Alpha is pi by 3. So you have this position as well as this position as the required positions, right? So now x is equal to n pi plus pi by 3 is the general solution where n belongs to integers. Now, what is the principal solution? So principal solution is nothing but, so the solution is in the first rotation. So you have pi by 3, that's one principal solution. And the next principal solution, you should not write it as minus pi by 3 because minus pi by 3 is a negative angle. That cannot come. So you have to go like this. So this is the required answer. So what I do is 2 pi minus pi by 3. So this is pi by 3. So this angle is 2 pi minus pi by 3. So that is 300 degrees, right? Pi by 3 is 60. 360 minus 60 is 300 degrees. So 300 degrees is 5 pi by 3. So these two are the principal solutions to this equation. This is the general solution. Now let us go for the third. Cot x is equal to minus root 3. Cot x is equal to minus root 3. So what is the quadrant diagram for cot x? Plus, minus, plus, minus. Now cot x is given as minus root 3, a negative number. So what is the basic angle? I won't find any angle in the first quadrant because in the first quadrant cot is positive. So corresponding to minus root 3, you need to go to second and third quadrant, second and fourth quadrants. Either this or this, anything is okay. So what I do is, so I'll go to the fourth quadrant. So corresponding to which angle cot is equal to minus root 3? Again, root 3 corresponds to 30 degrees for cot. Cot 30 is plus root 3. So minus root 3 comes in the allied position for 30 degrees. So you have minus 30 degrees. This is the position where cot will be equal to minus root 3. So I can write it as cot of minus pi by 6. So cot x is equal to minus root 3, and minus root 3 can be written as cot of minus pi by 6. So now once you have cot x is equal to cot alpha, so x is equal to n pi plus alpha plus minus pi by 6. That is equal to n pi minus pi by 6. So this will be the general solution for this. So you might be wondering, can I take, instead of minus pi by 6, can I take 5 pi by 6? Yes, you can take plus 5 pi by 6 also. In that case, the solution will be n pi plus 5 pi by 6. So both are right. Okay. And what is the general solution? Sorry, what is the principal solution? Principal solution is nothing but the first 5 pi by 6. So the first solution is 5 pi by 6. The second solution is 2 pi minus pi by 6. That is 330 degrees. It is 11 pi by 6. So these are the principal solutions. This is the general solution. So now let us go for our fourth question. So fourth question is cosecant x is equal to minus 2. Right? So the quadrant diagram for cosecant looks like plus, plus, minus, minus. So cosecant is minus, so I'll get some angle in the fourth quadrant. So cosecant x is equal to minus 2 implies sine is minus 1 by 2. So 1 by 2 corresponds to 30 degrees. So minus 1 by 2 should correspond to minus 30 degrees, minus pi by 6. So minus 2 can be written as cosecant of minus pi by 6. So cosecant x is equal to cosecant minus pi by 6. So x is equal to n pi plus minus 1 whole power n times minus pi by 6. So this will be the general solution to this equation, cosecant x is equal to minus 2. So you can take a minus common. So you can write it as minus 1 whole power n plus 1 also. And what is the principal solution? So you have one solution here and another solution here, allied positions. So one solution is pi plus pi by 6, 2 pi minus pi by 6. So those are the principal solutions. Pi plus pi by 6, 180 plus 30 degrees, 210 degrees. So the principal solutions are 210 degrees or 7 pi by 6 and 330 degrees, 11 pi by 6. So these are the principal solutions. This is the general solution. So this is how you analyze questions of type 1 if numbers are given. So next, let us look at a slight variation from the previous questions. So the equation given is sine 2x is equal to half. So how do we solve this? So this can also be solved by converting this into a standard type of equation. So sine 2x is equal to half can be written as sine of pi by 6, right? Sine 2x is equal to sine pi by 6. Now we have to consider 2x as an entity. 2x as an entity, sine of something is equal to sine of something. So this implies from the formula, this something has to be equal to n n pi plus minus 1 whole power n times pi by 6. We write the general solution. So the general solution for 2x is n pi plus minus 1 whole power n into pi by 6. So this implies the general solution for x is equal to n pi by 2 plus minus 1 whole power n times pi by 12. So this is the general solution for this equation. So what you need to do if you have something instead of x, so you have to take that as something and write the general solution first and then get the correct solution for x. Now, how many principal solutions does this equation have? We have seen till now that sin x is equal to something will have two solutions usually in one rotation. So if you have 2x in the place of x, the number of solutions in one rotation increases. Let us see how it is happening. So now x is equal to, so if you want the principal solutions, I want the solutions from 0 to 2 pi. So if you put n is equal to 0, if you put n is equal to 0, minus 1 whole power 0 is 1 times pi by 2, you have pi by 12, which is in between 0 and 360 degrees. Next, if you put n is equal to 1, you have 1 times pi by 2 plus minus 1 whole power 1 is minus 1. So pi by 2 minus pi by 12. Pi by 2 minus pi by 12 is 6 pi by 12 minus pi by 12 is 5 pi by 12. This is the next solution. If you put n is equal to 2, so you have 2 into pi by 2, pi plus minus 1 whole square is plus 1. So you have pi plus pi by 12. So you have pi plus pi by 12, that is 13 pi by 12 is the next solution. Next, if you put n is equal to 3, 3 pi by 2 plus minus 1 whole cube is minus 1. 3 pi by 2 minus pi by 12. 3 pi by 2 minus pi by 12. So if you multiply this with 6, 18 pi by 12 minus pi by 12 is 17 times pi by 12. Now if you put n is equal to 4, you have 2 pi plus something. You are going beyond 2 pi. So these are the 4 principal solutions. So instead of x, if you have 2x, the 2 principal solutions are now becoming 4 principal solutions. So these are the principal solutions to this question. So next, the question given is tan 3x minus pi by 4 is equal to 1. So inside tan, instead of x, you have 3x minus pi by 4, that's an entity. So how do we solve this? So tan of 3x minus pi by 4 is equal to 1 can be written as tan pi by 4, right? So now tan of something is equal to tan of something. So this implies this something, which is 3x minus pi by 4, has to be equal to, so with respect to tan, the solution is n pi plus alpha, right? N pi plus pi by 4. So 3x minus pi by 4 is equal to n pi plus pi by 4. This implies 3x is equal to n pi, it's minus pi by 4, if it goes onto that side, you get pi by 4 plus pi by 4 is pi by 2. And this implies x is equal to n pi by 3 plus pi by 6. N pi by 3 plus pi by 6. This implies, so this is the general solution. If I want the principal solutions, I just need to search for solutions in the first rotation. So if you put n is equal to 0, you're getting pi by 6. So if you're putting n is equal to 1, pi by 3 plus pi by 6 is pi by 2. If you put n is equal to 3, pi plus pi by 6. If you put n is equal to, 2, n is equal to 1. So this corresponds n is equal to 0, this corresponds n is equal to 1. So corresponding to n is equal to 2, you have 2 pi by 3 plus pi by 6. 2 pi by 3 is plus pi by 6. So 4 pi by 6 plus pi by 6 is 5 pi by 6. It is also in the first rotation. Now if you put n is equal to 3, you have pi plus pi by 6. That is 7 pi by 6. This is also okay. If you put n is equal to 4, 4 pi by 3 plus pi by 6. 4 pi by 3 plus pi by 6. That is 9 pi by 6 is 3 pi by 2. So corresponding to n is equal to 5. You have 5 pi by 3 plus pi by 6. 5 pi by 3 plus pi by 6. This is 11 pi by 6. So this is also okay. You're going to 330 degrees. You have come very close to 360 degrees. Now if you put n is equal to 6, you have 2 pi plus pi by 6. It's 360 plus some angle. You're going beyond 360 degrees. So that cannot be considered in the principal solution. So you have 1, 2, 3, 4, 5, 6. 6 principal solutions. So as you can see here, you can see a pattern of increase in the number of principal solutions. For sin x is equal to half, if you have order of x, you have 2 principal solutions in one rotation. So if the order is of 2x, the number of principal solutions is becoming 4. If the order is of 3x, the number of principal solutions is going to 6. So usually the number of principal solutions will be equal to 2 times whatever is the multiple here. Whatever is the multiple here. So whenever you multiply x with some number, it increases the number of principal solutions those many times. So the second type of simplest trigonometric equations are equations of this type. Sin square theta is equal to sin square alpha. Cosecant square theta is equal to cosecant square alpha. Cos square theta is equal to cos square alpha. Secant square theta is equal to secant square alpha. Tan square theta is equal to tan square alpha. Cot square theta is equal to cot square alpha. So what the difference between type 1 and type 2 is, type 1 does not have squares, type 2 have squares. So now let us take an example and see how the equations of this type can be solved. So for example, if sin square theta is equal to 1 by 2. So you need to solve this. You need to find the general solution for this. So 1 by 2 can be written as 1 by root 2 whole square. And 1 by root 2 is nothing but sine of 45. So this is sine square of pi by 4. So sine square theta is equal to sine square pi by 4. Now I'll try to solve this equation. So sine square theta is equal to 1 by 2. This implies sine theta is equal to either plus 1 by root 2 or minus 1 by root 2. So sine theta can be either plus 1 by root 2 or minus 1 by root 2. So now sine theta is equal to plus 1 by root 2 became the equation of type 1. Sin theta is equal to minus 1 by root 2 is also an equation of type 1. So the equation of type 2 contains 2 equations of type 1. So if you draw the quadrant diagram for sin theta, so now sin theta is equal to 1 by root 2. The quadrant diagram is plus, plus, minus, minus. So sin theta is equal to plus 1 by root 2 in the first quadrant at 45 degrees and in its allied position in the second quadrant 3 pi by 4. So these two positions give you sin theta is equal to 1 by root 2. Now sin theta can also be equal to minus 1 by root 2. That means this position as well as this position also comes. So in one rotation you have 4 positions. 4 positions which satisfy this equation. So what are the answers that you have? Theta can be equal to plus or minus pi by 4. Right? And pi plus or minus pi by 4. Next, 1 complete rotation plus or minus pi by 4. 1.5 rotation plus or minus pi by 4. 3 pi plus or minus pi by 4. So on. So all these are solutions to this equation. And how do I write this in a general form? So theta can be written as n pi. You are getting all integral multiples of pi plus or minus pi by 4. So pi by 4 is nothing but this angle alpha. So whenever you have an equation involving squares, so what you try to do is, let us try to express sine square theta and is equal to sine square of some number alpha. So whatever number is given, you have to express this in the form of sine square of alpha. You have square here. And the answer will be n pi plus or minus pi by 4. And the interesting thing in type 2 is, this solution works for all these equations. So let us see why this happens. So if you have cos square theta is equal to cos square alpha, if you have cos square theta is equal to 3 by 4. So what is the quadrant diagram for this? So this implies cos theta can be equal to plus or minus root 3 by 2. You can have plus root 3 by 2 or minus root 3 by 2. So the quadrant diagram is plus plus minus minus. So corresponding to plus root 3 by 2, you have plus 30 degrees and minus 30 degrees. And corresponding to minus root 3 by 2, you have the allied positions in the next two quadrants. So effectively that quadrant diagram looks exactly same as the quadrant diagram for sine theta. And similarly for tan also. So tan is positive in the first and third quadrants, negative in the second and fourth quadrants. Correspond to tan theta is equal to positive square root, you get roots in these two quadrants. Negative square root, you get roots in these two quadrants. So here also the quadrant diagram looks exactly same. That means in one rotation you're getting 4 solutions. In type 1 you have got only 2 solutions per revolution. So here you have again 4 solutions exactly same. So you have the solution for all of this in the same form. So for all these types of equations, the solution looks like theta is equal to n pi plus r minus alpha. So whenever you see equations involving square, the solution is n pi plus r minus alpha. So if you take another example, so you need to solve tan square theta is equal to 3. This is in the type 2 form. That is, you have a square for trigonometric ratio. So tan square theta is equal to 3. So what you need to do is you need to try to express 3 as some tan square of alpha. So 3 is nothing but root 3 whole square. That's nothing but tan pi by 3 whole square. So tan square theta is equal to tan square of pi by 3. And from now you don't need to do the derivation. So you can directly write theta is equal to n pi plus r minus pi by 3 as the answer. So every equation of this form has the solution of the same type. So theta is equal to n pi plus r minus pi by 3 is the solution. And for equations like this, in one rotation, you get 4 possible answers. So if you were asked to find the principal solutions, you get pi by 3. So you have 4 positions like this, which work for this equation. So pi by 3 is one solution. Pi plus or minus pi by 3, that is 2 pi by 3 as well as 4 pi by 3 is the solution. And next you have the solution in the fourth quadrant, 2 pi minus pi by 3, that's 300 degrees, which is 5 pi by 3. So all these 4 are the solutions, principal solutions to this equation. So I hope you have understood the type 2 questions. So now let's go for type 3 questions. So type 3 equations are simultaneous equation type. That is, instead of giving you one equation, you'll be given 2 simultaneous equations. For example, so if sine theta has to be equal to half and cos theta has to be equal to minus root 3 by 2. So I want those values of theta for which sine theta will be equal to half and cos theta will be equal to minus root 3 by 2. So what is the general solution for this simultaneous set of equations? So what we analyze for this question is, okay, sine theta is equal to half. So what is the quadrant diagram for sine theta? Plus, plus, minus, minus. So sine theta will be positive in the first 2 quadrants, negative in the next 2 quadrants. So correspond to sine theta is equal to 1 by 2. Theta has to be equal to 30 degrees, right? Theta is 30 degrees in the first quadrant and its allied position in the second quadrant is 150 degrees. So at these 2 positions, sine theta will be equal to half. Now if you draw the diagram for cos theta, quadrant diagram for cos theta. For cos theta, it is plus, plus, minus, minus. That's the quadrant diagram for cos theta. Now cos theta has to be minus root 3 by 2. So root 3 by 2 corresponds to 30 degrees for cos. Cos, that is root 3 by 2. But I want minus root 3 by 2. So I cannot go to first and fourth quadrants, because in the first and fourth quadrants, it is 30 and minus 30. The value of cos theta is positive. I want my value of cos theta to be negative. So I need to go to the next 2 quadrants, right? So this angle is 150 degrees, this angle is minus 150 degrees. these are allied positions to theta is equal to 30 degrees. Now sin theta will be equal to half at these two positions of the rays. Cos theta will be equal to minus root 3 by 2 at these two positions. So if these two simultaneously should happen, this also has to happen, this also has to happen. Obviously the ray has to stop at this position because these two are same. So the answer is something like we have only one position per revolution which satisfies both these equations simultaneously, and that this position for these values is 150 degrees, that is 5 pi by 6. So half can be written as sine of 5 pi by 6 minus root 3 by 2 can be written as cos of 5 pi by 6. So for simultaneous equation type, you need to first search for some solution which works for both the equations, and then we know that you're getting only one solution per revolution. So next revolution, so next time you get the same position when theta is equal to 2 pi plus 5 pi by 6. Next time 4 pi plus 5 pi by 6. So 5 pi by 6 is an answer. Next revolution 2 pi plus 5 pi by 6. Next revolution 4 pi plus 5 pi by 6. So what is the general solution for this? 2n pi plus r minus, sorry, you don't have a minus, 2n pi plus 5 pi by 6. So the solution for simultaneous equations look like this. So you have only one solution for revolution. So the answer for this is 2n pi plus 5 pi by 6. So now let us look at the general solution for simultaneous equations. So how we write in a formula form. So in type 3 questions, you'll have questions like this. Sin theta is equal to sin alpha and cos theta is equal to cos alpha. You'll be given two equations. So what is the solution for this? Theta is equal to 2n pi plus alpha. So this is the general solution to this set of equations. So now you need to see this carefully. Sin theta is equal to sin alpha and cos theta is equal to cos same alpha. So that means for the same value of alpha, these two equations have to be valid. We need to search for that value. For example, so if you have sin theta is equal to half and cos theta is equal to 1 by root 2, so you cannot have solution for this, because when sin theta is equal to half, cos theta has to be equal to either plus root 3 by 2 or minus root 3 by 2. For only those values of cos theta, we can find the solution for theta. So if you are given these two simultaneous solutions, the answer is no solution, because when sin theta is equal to half, cos theta cannot be equal to 1 by root 2. So this solution has to be used if the values of given trigonometric ratios are nicely working out. And you can have any two equations, any two simultaneous equations, for example sine equation and a tan equation also. For all those simultaneous equations, the solution is 2n pi plus alpha. I hope you have understood the logic also. So now, before going forward, let us summarize all the three types. So in this video, let us summarize what we have learned in trigonometric equations till now. So we have seen what trigonometric equation is, what the meaning of general solution versus principal solution is. So I hope you have remembered these two topics. These are important. What is general solution and what is principal solution. And next we have seen simple equations of three types. So for type 1, you have three different types of solutions. For sine, correspond to sine and cosecant, correspond to equations involving sine and cosecant. The solution is theta is equal to n pi plus minus 1 whole power n times alpha. Corresponding to the equations involving cos and secant, theta is equal to 2n pi plus r minus alpha, and corresponding to tan and cot, theta is equal to n pi plus alpha. And for these equations, usually we have two solutions per revolution. These equations, you have two solutions per revolution. Next, if you go to type 2, these type involving squares of trigonometric equations. So whenever you have squares, so whatever may be the trigonometric ratio you're dealing with, the answer is always n pi plus minus alpha. If you have sine square theta is equal to sine square alpha or any trigonometric ratio, theta is equal to n pi plus or minus alpha. Now if you go to type 3 is the simultaneous equation type. So if you have two equations of the form sin theta is equal to sin alpha and cos theta is equal to cos alpha, theta is equal to 2n pi plus alpha. So these are the standard results which you need to remember if you want to go forward in this topic. So now once you have made sure that you have remembered all this, now let us go to our problem section. So in this video, let us look at a very important type of question, which is A cos x plus B sin x type questions. For example, assume that you're given this question. You're asked to solve 3 cos x plus 4 sin x is equal to 2. So how do we solve this? So we've already seen what we do with the expression A cos x plus B sin x. We can convert this expression into a single trigonometric ratio by multiplying and dividing with root of a square plus b square. So what we do is we consider a right angle triangle whose sides are 3 and 4. Whose sides are 3 and 4. Once you draw this triangle, you can always complete the hypotenuse. And whatever angle is here, let us call that angle as alpha. Let's call this angle as alpha. This alpha is a fixed angle because this is an angle whose tan is 3/4. Now if 3 and 4 are the sides, obviously the hypotenuse will be 5 units, right? So what I do is I'll divide both sides with a number 5. So 3 cos x plus 4 sin x by 5 is equal to 2 by 5. Right? 3 cos x plus 4 sin x by 5 is equal to 2 by 5. Now, what can 3 by 5 be written as? Because this by 5 is for both of these expressions. 3 by 5 can be written as cos alpha, right? So I can write this expression as cos alpha times cos x plus 4 by 5 can be written as, 3 by 5 can be written as sin alpha, right? So sin alpha times cos x, and 4 by 5 can be written as cos alpha times sin x is equal to 2 by 5. This implies, as you can see, this is of the form sin a cos b plus cos a sin b. This can be written as sin of a plus b sin of x plus alpha is equal to 2 by 5. Now what I do is I'll draw another triangle, other right angle triangle, whose one of the right angle side is 2 and the hypotenuse is equal to 5 this time. So let this be 2 and let this be 5. I can always draw a right angle triangle with these properties. Let the angle that is formed here be equal to beta. So we don't know these angles right now, but we can refer to the tables and get this angle. This is an angle whose sine is 2 by 5. This is an angle whose sine is 2 by 5. So 2 by 5 can be written as sine of beta. This implies sine of something is equal to sine of something. So x plus alpha is equal to n pi plus minus 1 whole power n times beta. And this finally implies x is equal to n pi plus minus 1 whole power n times beta minus alpha. So this will be the required solution to this equation. So I hope you can follow what we are doing. So these numbers are not standard numbers. So the angles that correspond to these numbers are not known to us. So what we do is we assume them as some alpha and beta. And if it's required, we can refer to these angles from the trigonometric tables. So first I draw a triangle with sides as the numbers given here. So I get an angle alpha. So I can convert this into a single trigonometric ratio. And similarly, you can draw a right angle triangle with these two numbers and you get a trigonometric ratio. Once you equate them, you get the answer. It's not necessary that I always convert this into sine. I can also convert this into cos. So for example, if I draw a triangle whose this side is 4 and this side is 3 and this side will be equal to 5, and I consider this angle as some angle delta. Let's call this an angle. Let us call this angle delta. Now 3 by 5 can be written as cos delta, 4 by 5 can be written as sin delta. So this equation becomes cos delta cos x plus sin delta sin x is equal to 2 by 5. So this is cos of a minus b, x minus delta is equal to 2 by 5. Now I'll draw a triangle whose this side is 2 and this side is 5. I'll consider this as gamma. So gamma is an angle whose cos is 2 by 5. So 2 by 5 can be written as cos gamma. So x minus delta is equal to 2n pi plus r minus gamma. X is equal to 2n pi plus r minus gamma plus delta. So this can also be done. So these two solutions refer to exactly same values, but these two look different. But once you expand both of them into roster form, you get the same answers from these two set builder forms. So I hope you have understood how we do the questions of the type a cos x plus b sin x is equal to some number. So let us look at this question. In this question you asked to find the values of c for which the equation 3 sin x plus 4 cos x is equal to c has exactly one principal solution, exactly two principal solutions, no principal solution. So how do we do this? We do the same process as we have done before. So what I first do is I'll try to convert this side into a single trigonometric ratio. So 3 sin x plus 4 cos x by 5 is equal to c by 5. So this implies, so if I draw a triangle whose right angled sides are 3 and 4, the hypotenuse automatically becomes 5. Whatever angle is formed here, I call it alpha. So 3 by 5 can be written as sin alpha. 3 by 5 can be written as sin alpha sin x plus 4 by 5 can be written as cos alpha cos x is equal to c by 5. So this implies this is nothing but sine of x plus alpha is equal to c by 5. So now this equation has become a standard simple equation. Sine of something is equal to c by 5. So this equation usually have two principal solutions or one principal solution or no principal solutions. So when will this have no principal solutions? If it have no principal solutions, that means the c by 5 has to be lying outside the range of this side, because sine is always less than or equal to 1 and greater than or equal to minus 1. So sine always lies between minus 1 and plus 1. But if this number is more than 1, so you won't have a solution. So this equation does not have principal solutions if c by 5 is greater than 1 or less than minus 1. That means c is either greater than 5 or less than minus 5. In these two cases, you have no principal solutions. Next, if this has to have only one principal solution, exactly one principal solution. So we have already seen that sin x is equal to plus 1 and sin x is equal to minus 1 has only one principal solution. For all other values, you have two principal solutions. So sin x, if it is equal to 1 or minus 1, the maximum and minimum values, you have only one principal solution. That is pi by 2 and 3 pi by 2. You won't have highlight positions for that. So one principal solution if c by 5 is equal to plus r minus 1, that is c is equal to plus r minus 5. And for all the remaining values which are okay, the equation sine of something is equal to something has two principal solutions. That means if c by 5 lies between minus 1 and plus 1, that is c lies between minus 5 and plus 5, you'll have two principal solutions. Two principal solutions. So these are the three cases that you encounter for equations like this. So in this video, let us look at extreme value questions or questions based on boundedness of trigonometric functions. So the first question that we're going to see is, you need to solve the equation cos x into cos 6x is equal to minus 1. So how do we solve this? To solve this directly will be a very hectic task. Because cos 6x, if you try to expand it, it will be a 6th power of cos x. You'll get an equation in cos x whose degree is 6. So cos x into 6th degree, you get a 7th degree equation. You cannot solve it. So what I observe here is cos x into cos 6x is equal to minus 1. Cos x is a number which lies in between minus 1 and plus 1. That means cos x will always be a fraction unless it is minus 1 and plus 1. Similarly, cos 6x also lies between minus 1 and plus 1. So the product of these two numbers have to be equal to minus 1. So if this is a fraction and this is a fraction, the product of two fractions can never be equal to a complete integer. So if this has to be an integer, there is only one option where cos x and cos 6x should be such that the product is equal to minus 1. So for this to happen, cos x to be equal to 1 and cos 6x has to be equal to minus 1, or vice versa. That is, cos x is equal to minus 1 and cos 6x is equal to 1. So for this to happen, one of this has to happen. So let us see the first case. Cos x is equal to 1 implies x is equal to 2m pi, right? Something which you have derived already. And cos 6x is equal to minus 1. This implies 6x is equal to 2m plus 1 times pi. So x has to be equal to an even multiple of pi and 6x has to be equal to an odd multiple of pi. This implies x has to be equal to 2m plus 1 times pi by 6. So for this condition to be valid, cos x is equal to 1 and cos 6x is equal to minus 1, x has to be an even multiple of pi and also an odd multiple of pi by 6. So can an even multiple of pi be equal to an odd multiple of pi by 6? No, because 2n pi can be written as 12n times pi by 6, right? It's nothing but 12n times pi by 6. This is an odd multiple of pi by 6. This is an even multiple of pi by 6. Both cannot happen simultaneously. It means there is no solution according to case 1. So this case does not have a solution. Let us go to case 2, where cos x is equal to minus 1 and cos 6x is equal to 1. So x has to be equal to an odd multiple of pi and 6x has to be an even multiple of pi. 6x has to be equal to 2m pi. So this implies x has to be equal to 2m times pi by 6. There is an even multiple of pi by 6. So if you go to this, x is equal to 2n plus 1 times pi by 6 into 6, right? So the first condition says that x has to be of the form 6 times 2n plus 1 times pi by 6. And for this to be valid, x has to be of the form 2m times pi by 6. Even multiple of pi by 6, and this is also an even multiple of pi by 6. So this is all even multiples of pi by 6. This contains only certain even multiples of pi by 6. So x has to be satisfying both the conditions. So obviously this is a subset of this. This is a subset of this. So intersection will be equal to this, right? Because all the numbers present in this are even multiples of pi by 6. But this does not cover all even multiples. If you put n is equal to 1, you get 6 pi by 6. Which comes if you put m is equal to 3. If you put n is equal to 1, you get 6 into 3, 18 pi by 6. You get 18 pi by 6 here also. So all the solutions available in this are also solutions for this. So effectively, the common solution for these two is x is equal to 2n plus 1 times pi. It means if x is an odd multiple of pi, this equation is valid. Cos x will be equal to minus 1 and cos 6x will be equal to plus 1. Hence, the product of these two will be equal to minus 1. So the answer to this equation is x is equal to 2n plus 1 times pi, and the principal solutions are only 1, All the other solutions are not principal solutions. So in this question, you're asked to find the number of ordered pairs x comma y in open 0 to 2 pi such that sin x into cos y is equal to 1. So the equation that needs to be satisfied is sin x times cos y is equal to 1. This is also a question based on the boundedness property of sin and cos. We know that sin always lies between -1 and +1 and cos always lies between -1 and +1. The product of these two will be equal to 1 only in two cases. That is, if this has to be equal to 1, then sin x is equal to 1 and cos y has to be equal to 1, or both of them can be equal to 1, or sin x is equal to -1 and cos y is equal to -1. So only in these two cases can this be valid. So this implies, let us see these cases, sin x is equal to 1 implies x is equal to, where will sin x be equal to 1? We have already solved this, 4n plus 1 times pi by 2, and cos y is equal to 1 implies y is equal to 2m pi, even multiples of pi. Cos y will be equal to 1. So this is one option, or sin x has to be equal to -1 implies x is equal to 4n minus 1 times pi by 2. We have already derived this. And y should be equal to 2m plus 1 times pi, odd multiples of pi. So now let us look for solutions in open 0 to 2 pi. So for this case, x is equal to 4n plus 1 times pi by 2. So if you put n is equal to 0, you get pi by 2. X can take values of pi by 2. And the next value is n is equal to 1, that is 5 times pi by 2. This is beyond 2 pi. So you have only one solution between 0 to 2 pi, and y is equal to 2m pi, even multiples of pi. So you get the first solution as 0, next solution is 2 pi, next solution is 4 pi, so on. But none of these are valid because I want solutions only in open 0 to 2 pi. So I don't want 0 or 2 pi. So effectively, this part of the solution does not give you any solution. If you go to the second one, x is equal to n minus 1 times pi by 2, 4n minus 1 times pi by 2. So x can take the value of, if you put n is equal to 1, you get 3 pi by 2. This is okay. And the values of y are odd multiples of pi. If you put m is equal to 0, you get pi. All the other values are beyond 0 to 2 pi. So this x and this y both lie in 0 to 2 pi. Hence, this is a solution to this equation. Hence, the number of ordered pairs satisfying this equation is only 1. So the answer is only 1. So in this question, given that 3 sin x plus 4 cos ax has to be equal to 7, this equation has to have at least one solution. If that is so, how many possible values of a are there? So again, this is also a question based on the boundedness of trigonometric functions, because sin x can take a maximum value of 1 and cos ax can also take a maximum of 1. So only if both take the maximum values can this expression be equal to 7. So 3 plus 4 is equal to 7. So even if one of them go below 1, we cannot get 7 as the sum of these two. So if this equation has to be valid, so sin x has to be equal to 1 and cos ax should also be equal to 1. This implies x has to be equal to 4n plus 1 times pi by 2, right? And ax has to be equal to, cos x is equal to 1, that means even multiples of pi, 2m pi. So x has to be equal to 4n plus 1 times pi by 2, ax has to be equal to 2m pi. So this implies x is equal to 2m pi by a. So for this equation to have at least one solution, we should have some solution which looks like this as well as this. My x has to look like 4n plus 1 times pi by 2. My x also have to look like 2m pi by a. So for these two types of solutions to have a common solution, you need 4n plus 1 times pi by 2 to be equal to 2m pi by a. This pi and this pi gets cancelled. This implies a has to be of the form 4m by 4n plus 1. So a has to be of the form 4m by 4n plus 1. So if a is of this form, you will have at least one solution to this equation. For example, a can be of the form m is equal to 1. I'll put n is equal to 1. That is 4 by 4 plus 1 is 4 by 5. So on, you can have different values of a which satisfy this condition. So in this question, you're given the equation cos power 50x minus sin power 50x is equal to 1. You're asked to solve this. Obviously, power 50 equation, degree 50 equation cannot be solved directly. So this question is a question based on boundedness property. So what I do is cos power 50x is equal to 1 plus sin power 50x, right? Cos power 50x is equal to 1 plus sin power 50x. So just observe this part of the equation. 1 plus sin power 50 is always greater than or equal to 0. It cannot be negative. So 1 plus some number which is greater than or equal to 0. That is RHS is always greater than or equal to 1. But the LHS is cos x power 50. This will always be less than or equal to 1. So if these two have to be equal, there is only one condition. There is only one way in which both can be equal. That is cos power 50x is equal to 1. And this is also equal to 1 plus sin power 50x. If both sides are equal to 1, then there is a chance that these two are equal. That means cos x is equal to plus or minus 1 and sin x should be equal to 0, right? Because 1 is equal to 1, sin x has to be equal to 0. So for this equation to be valid, cos x has to be plus or minus 1 and sin x has to be equal to 0. Cos x is equal to plus or minus 1 implies cos square x is equal to 1 effectively. So x is equal to n pi. This 1 corresponds to cos square 0, so you won't have anything. X is equal to n pi. And sin x has to be equal to 0. That means x is also equal to n pi. For both the equations, the solution is n pi. Hence, the answer, the solution for this question is x is equal to multiples of pi, where n belongs to integers. That's the answer to this question. So in this question, you're given the equation 12 sin x plus 5 cos x is equal to 2y square minus 8y plus 21. You have a trigonometric expression here, you have a quadratic expression here. This is in terms of x, this is in terms of y. So you're asked to solve this. You're asked to solve for both x and y. So how do we do this? Again, this is also a question based on boundedness. So obviously you cannot directly try to solve this because trigonometric expression, quadratic expression, they cannot be solved simultaneously. And one side is in the terms of x, the other side is in terms of y. So you cannot directly try to solve it. So what I try is, first I'll try to see the minimum value of this quadratic expression. So if you take 2y square minus 8y plus 21 is a quadratic expression. So the minimum value of this can be found out using the formula minus of d by 4 times a. That is equal to minus of, what is the discriminant of this? B square minus 4ac. B square is 64 minus 4 into a into c, that is 8 times 21. B square minus 4ac by 4 times a is 8. That is nothing but minus of, if you cancel 8 out, you get 8 minus 21. That is equal to 21 minus 8, which is equal to 13. 21 minus 8 is equal to 13, right? That means this value will always be greater than or equal to 13. So this is a formula which you get in the chapter of quadratic equations and expressions. Otherwise, if you want to do it directly, you can also use the method of completion of squares to get this value. So what you can do is you can write this expression as 2 times y square minus 4y plus 21. You just need to complete the square here. 2 times y square minus 4y plus 4 minus 4 plus 21. So y square minus 4y plus 4 becomes y minus 2 whole square. It is 2 times y minus 2 whole square minus 8 plus 21 is plus 13. So this expression can be written as 2 times y minus 2 whole square plus 13. Now we know that y minus 2 whole square is always greater than or equal to 0, into 2 is always greater than or equal to 0, plus 13 is always greater than or equal to 13. So we get the same answer from this formula and this method. Actually, this is derived by this method. So you can remember this formula, minus d by 4a gives you the minimum value of a quadratic expression whose leading coefficient is positive. Now this side we have found that is always greater than or equal to 13. Now let us analyze the LHS. 12 sin x plus 5 cos x. This is of the form a sin x plus b cos x. So we usually divide this with root of a square plus b square, that is 13 and 13. Root of 12 square plus 5 square is 13. So now if you draw a triangle whose sides are 12 and 5, so the hypotenuse becomes 13. So 12 out of 13 is nothing but sin theta, 5 out of 13 is cos theta. Is of the form sin a sin b plus cos a cos b. So cos of x minus theta times 13. 13 times cos x minus theta. So this can be written as 13 times cos of some x minus theta is equal to 2y square minus 8y plus 21. So cos is always less than or equal to 1. So this side is always less than or equal to 13. And this side is always greater than or equal to 13. For these two to be equal, both have to be equal to 13. So for this equation to be satisfied, cos x minus theta has to be equal to 1. That is 13 times cos x minus theta has to be equal to 13. So cos x minus theta has to be equal to 1, and this expression has to be exactly equal to 13. That means y has to be equal to 2. So if this is 0, then this value is 13. So y has to be equal to 2. Right? So if you want to do by the formula, this is the minimum value, and this minimum value occurs at minus b by 2a. That's the formula. It is minus of minus 8 by 2a is 4. It is equal to 2. You're getting the same answer. So y has to be equal to 2 for this equation to be valid, and cos x minus theta has to be equal to 1. So x minus theta has to be equal to 2m pi, right? Even multiples of pi. So x is equal to 2m pi plus theta. So this is the possible value of x, and this is the possible value of y. So where theta is some angle whose tan is equal to 12 by 5. Is tan is 2.4. So correspond to tan theta is equal to 2.4. You get some angle theta. So that is the angle which you need to use here. So I hope you have understood this question. So let us look at this question. You're asked to find the number of solutions in 0 to 4 pi to the equation 12 cos cube x minus 7 cos square x plus 4 cos x is equal to 9. So this is a similar question to previous type quadratic, but this time we have a cubic. So we follow the same process. We try to factorize this equation. So once we factorize, you get small equations which might be solvable. So first, this is a cubic equation in cos x. That's what your observation is. So let cos x is equal to t. So if cos x is equal to t, you have 12t cube minus 7t square plus 4t minus 9 is equal to 0. So this is a cubic equation. There is no standard process to solve this. So we need to go for trial and error. So we substitute different values for t and see whether they satisfy the equation or not. So in this equation, clearly t is equal to 1 is satisfying this equation. See? So if you put t is equal to 1, so you're getting 12 minus 7 plus 4 minus 9. 16 minus 16 is equal to 0. So t equal to 1 is one of the root of this. That means t minus 1 is a factor for this. So let us find the other factor. So I'll divide this expression with t minus 1. So 12t cube minus 7t square plus 4t minus 9. So if you divide this with t minus 1, you have 12t square. So you have 12t cube minus 12t square minus plus. So you have 5t square plus 4t. So you have plus 5t. So 5t square minus 5t minus plus. So 9t minus 9. So plus 9s are 90 minus 9. We have 0. That means this can be factorized into t minus 1 into 12t square plus 5t plus 9 is equal to 0. So either this is equal to 0 or this is equal to 0. This implies either t is equal to 1 or 12t square plus 5t plus 9 is equal to 0. This is a quadratic equation. This can be directly solved. T is equal to minus b plus minus root of b square minus 4ac, 4 into 12 into 9. That is 4 into 12 is 48 into 9. 48 times 9 is a very large number compared to 25, right? So you have a negative number inside the square root. That means this equation does not have real roots. This quadratic equation does not have real roots. So you have only one solution. T is equal to 1. That means cos x has to be equal to 1. So if this equation has to be valid, cos x has to be equal to 1. So now we are asked to find the number of solutions in 0 to 4 pi. If you draw the quadrant diagram, so for cos, the signs are plus, minus, minus, plus. So cos x is equal to 1 when x is equal to 0, right? So this is the position correspond to cos x is equal to 1. So if you go from close 0, so you have one solution in one rotation. And if you're going for other rotation, you have crossed this position 2 times at 0, 2 pi, and next at 4 pi, but you have open 4 pi. So you cannot consider 4 pi as the answer. So obviously, as you can see, cos x is equal to 1 only at this position. So between 0 to 4 pi, you come to this position 2 times at 0 and 2 pi. So the answer is equal to 2. Number of solutions in close 0 to 4 pi is equal to 2. So I hope you have understood this concept of factorization, and this will be used if you have a higher degree trigonometric equation. So in this question, you are asked to solve this equation. 3 tan 2x minus 4 tan 3x is equal to tan square 3x into tan 2x. So if you observe this equation, you have tan 2x and 3x. This equation is made up of tan 2x and tan 3x. Now, so how do we analyze this? What I try to do is I'll try to factorize this equation. So 3 tan 2x. What I'll do is I'll separate 3 tan 3x and minus tan 3x. Minus 4 tan 3x can be written as minus 3 tan 3x, again minus tan 3x is equal to tan square of 3x into tan of 2x. So this implies 3 times, if you take 3 as common, you have tan 2x minus tan 3x is equal to, so if you send minus tan 3x onto that side, you get plus tan 3x. So you have tan 3x in both the terms. So if you take tan 3x as common, you have 1 remaining here plus tan 2x into tan 3x. So this implies, so do you remember some formula? You have tan 2x minus tan 3x here, 1 plus tan 2x tan 3x here. I'll bring this to the denominator and I'll send this here. So 3 times tan 2x minus tan 3x by 1 plus tan 2x tan 3x is equal to tan 3x. Now what is What is this? A formula for tan A minus tan B by 1 plus tan A tan B is tan of A minus B. So 3 times tan of 2x minus 3x is tan of minus x is equal to tan 3x. So this implies minus 3 tan x is equal to tan of 3x. So this implies if you send minus 3 tan x onto that side, you get plus 3 tan x plus tan 3x is, what is the formula for tan 3x? 3 tan x minus tan cube x by 1 minus 3 tan square x is equal to 0. So you have tan x in each of this term if you take tan x as common. So you have tan x times 3 plus if you take tan x as common from this. So you have 3 minus tan square x by 1 minus 3 tan square x is equal to 0. So if you take LCM, so tan x times 3 minus 9 tan square x plus 3 minus tan square x by 1 minus 3 tan square x is equal to 0. If you take the LCM, this becomes equal to 0. So you have tan x times 6 minus 10 tan square x is equal to 0. This implies tan x is equal to 0 or tan square x is equal to 6 by 10, that is equal to 3 by 5. So tan x is equal to 0 or tan square x is equal to 3 by 5. So this implies x is equal to n pi. So tan x is equal to 0. 0 can be written as tan 0. So you have x is equal to n pi, or tan square x is equal to 3 by 5. The solution is n pi or m pi plus or minus some angle alpha such that tan x is equal to root of 3 by 5. Such that alpha is some angle such that tan alpha is equal to root of 3 by 5. So you have these two as the solutions to this equation. So what we have done in this question is we have tried to factorize the equations and take some terms as common and form a quadratic, and I have solved the quadratic. So let us look at this question. Sin 2x plus cos x is equal to 0. How do I solve this? So let me solve this in two different ways. So the first is the method of factorization. So can I factorize this? Can I divide this into two factors? To do that, what I do is sin 2x, you know that it is 2 sin x cos x plus cos x is equal to 0. So you have cos x here as well as here. So cos x, if I take it as common, I get 2 sin x plus 1 is equal to 0. So this implies something into something is equal to 0, implies either cos x is equal to 0 or 2 sin x plus 1 is equal to 0. So cos x is equal to 0 or 2 sin x plus 1 is equal to 0. This implies, what is the general solution of cos x is equal to 0? We've already derived this. So the odd multiples of pi by 2 satisfy this equation. So x is equal to 2n plus 1 times pi by 2 odd multiples, or sin x is equal to minus half. So correspond to minus half, what is the angle that you get? So I can take minus half as sine of minus pi by 6, right, in the fourth quadrant. So sin x is equal to sine of minus pi by 6. So x is equal to n pi plus minus 1 whole power n times pi by 6 with a minus sign. So minus sign can be included into minus 1 and the power can be written as n plus 1. So minus of 1 again, so minus 1 into minus 1 whole power n is minus 1 whole power n plus 1. So the solution is either this or this. So if you are asked to find the number of principal solutions, so you have pi by 2 and 3 pi by 2 as the principal solutions here. Pi by 2 and 3 pi by 2. And here, if you put n is equal to 0, n is equal to 0, you're getting minus pi by 6, that cannot be considered. Start with n is equal to 1. So you have pi plus pi by 6, that is 7 pi by 6 is okay. And if you put n is equal to 2, 2 pi minus pi by 6. 2 and the power becomes 3. So 2 pi minus pi by 6, that is 11 pi by 6. So these are the two principal solutions for this side. These are the two principal solutions for this side. So in total, you have 4 principal solutions for this equation. So this is one way of doing this. This method is called factorization method. So the other way to do this is, so how we can do this is sine 2x is equal to, so this cos x, if it goes onto that side, it become minus cos x. So can minus cos x be written as sine of something? So this can be written as, minus cos x can be written as something like sine of, can I write it as 3 pi by 2, because if sine has to be equal to minus cos x, sine has to be converted to cos, so this number has to be odd, and you have to get a minus also. So I will go for 3 pi by 2 minus x. So what is sine of 3 pi by 2 minus x? The quadrant is third quadrant, sine is negative, you get a minus, and the number is odd, so sine converts into cos, so you get minus cos x. So you can also put plus here, the same thing will come. So sine 2x is equal to sine of 3 pi by 2 minus x. So this implies sine of something is equal to sine of something. So I can write this as 3 pi by 2 minus x is equal to n pi plus minus 1 whole power n times 2x, right? Something has to be equal to n pi plus minus 1 whole power n times something. So I can write the reverse also, it doesn't really matter. So this is a solution for our equation. So let us try to analyze our solution. Because x is there here as well as here. I want to bring x onto one side. So first what I do is, minus 1 whole power n depends on whether n is even or odd. So first I will take two cases. Case 1, let n be equal to an even number 2m. If n is equal to a number of the form 2m, what happens? So 3 pi by 2 minus x is equal to 2m pi. If n is of the form 2m, minus 1 whole power 2m will be plus 1. So you get plus 2x. So this implies if x goes onto that side, 3x is equal to minus 2m pi plus 3 pi by 2. Minus 2m pi plus 3 pi by 2. So this minus 2m can be written as plus 2m, doesn't really matter, because m is an integer. M takes positive values as well as negative values. So if you can take this minus to m, minus m is also an integer. So this is of the form 2m pi plus 3 pi by 2. So this implies x is equal to, if you bring this 3 onto this side, 2m pi by 3 plus pi by 2. This is one solution to the equation. The case 2, if n is of the form 2m plus 1, it is an odd number. Now what happens is 3 pi by 2 minus x is equal to 2m plus 1 times pi. This minus 1 whole power odd number becomes minus 1. So you get minus 2x here. This minus 2x goes onto that side. So plus 2x minus x is equal to 2m plus 1 times pi minus 3 pi by 2. So the solution of x is either this or this. So as you can see, it looks quite different from the general solution of the same question obtained from the different process. But the final answers in the roster form will be same. There can be more than one different form to express a solution set builder form. We have seen that in the topic of sets. So these solution on the face value might look different, but if you expand them, we expect the same answers. For example, let us expand this. Let us find the principal solutions. Let us see whether you're getting the same positions or not. So what are the principal solutions for this? So put m is equal to 0, you're getting pi by 2. Put m is equal to 1, you are getting 2 pi by 3 plus pi by 2. 2 pi by 3 plus pi by 2, that is 4 pi plus 3 pi, 7 pi by 6. So put m is equal to for 0 you got pi by 2, for 1 you got 7 pi by 6. If you put m is equal to 2, 4 pi by 3 plus pi by 2. You're getting 8 pi plus 3 pi. That is 11 pi by 6. You're getting 11 pi by 6. Next, if you put m is equal to something like 3. So you're getting 2 pi plus pi by 2. You're going beyond 2 pi. So these are the three principal solutions from this side. So if you go to this side, put m is equal to 0. Pi minus 3 pi by 2 is a negative number. M is equal to 1. M is equal to 1. 3 pi minus 3 pi by 2 is 3 pi by 2. So you're getting 3 pi by 2 from this. Put m is equal to 2. 5 pi minus 3 pi by 2. 5 pi minus 3 pi by 2 is 10 minus 3. 7 pi by 2 is going beyond 2 pi. So this cannot be considered as a principal solution. So all the three positions, this position, this position and this position are being covered by this set builder form, and only this position is being covered by this. So effectively you're getting the same positions. The answers might look different, but once you expand this solutions in the roster form, they look same. So I hope you have understood why you're getting two different answers to the same question. So again, you might get two different answers, but what you need to check is once you expand them in roster form, you need to get the same numbers. Then both of them are correct. So let us look at this type of question where you need to convert products to sums. So you're given the question 4 cos theta plus pi by 6 into cos theta minus pi by 6 is equal to 1. So whenever you have product, the right hand side, if it is 0, that would be very nice, because if product of some things is equal to 0, either the first thing has to be 0 or the second thing has to be equal to 0. But here the product is given as equal to 1. So you cannot use that logic directly. So what I do here is, so 4 is nothing but 2 times 2 cos theta plus pi by 6 into cos of theta minus pi by 6 is equal to 1. This implies 2 times, what is 2 cos A cos B? You know the transformation formulas. 2 cos A cos B is nothing but cos A plus B plus cos A minus B. So cos of, what is the sum of these two? If you add these two, pi by 6 and minus pi by 6 gets cancelled. So 2 theta. 2 cos A cos B is cos A plus B plus cos of A minus B. If you subtract one from the other, theta and theta gets cancelled. Pi by 6 minus of minus pi by 6 is pi by 3 is equal to 1. This implies if you send this 2 onto that side, you get cos 2 theta plus cos pi by 3 is 1 by 2 is equal to 1 by 2. So this 1 by 2 and 1 by 2 gets cancelled. This implies cos 2 theta is equal to 0. Cos of 2 theta is equal to 0. This implies 2 theta is equal to, correspond to 0, we have already derived, odd multiples of pi by 2. So this implies theta is equal to 2n plus 1 times pi by 4. So this is the, where n belongs to integers, is the general solution of this equation. So if you want the principal solutions, you can put n is equal to 0, you get pi by 4. If you put n is equal to 1, you get 3 pi by 4. If you put n is equal to 2, you get 5 pi by 4. And if you have n is equal to 3, you have 7 pi by 4. And next solution will be 9 pi by 4, which is more than 2 pi. You cannot take that solution. So you have 4 principal solutions to this question. So let us look at this question. So you're asked to solve tan square theta plus 2 root 3 tan theta is equal to 1. This is a very standard type of question which falls in the category of quadratic type. So as you can see, you're given a quadratic in tan theta. So first what we do is let tan theta is equal to x. So the equation becomes x square plus 2 root 3x minus 1 is equal to 0. This is a quadratic equation. So what is the root of this quadratic equation? So x is equal to minus b plus or minus root of b square minus 4ac by 2a. There is minus 2 root 3 plus or minus root of b square 2 root 3 whole square is 12 minus 4ab, you have plus 4 by 2a. So that is equal to minus 2 root 3 plus or minus root 16 is 4 by 2. That is equal to, if you cancel this out, minus root 3 plus or minus 2. That means if this equation has to be satisfied, my value of x has to be equal to minus root 3 plus or minus 2. And what is x? X is nothing but tan theta. This implies tan theta is equal to either 2 minus root 3 or minus of 2 plus root 3. So now this has become a simplest equation of type 1. So tan theta is equal to this number, or tan theta is equal to minus of 2 plus root 3. Now to solve this equation, what you need to find is, you need to find an angle theta such that tan theta is equal to 2 minus root 3. So as you can see, 2 minus root 3 is positive. So you'll get some angle in the first quadrant. So I hope you remember the values of trigonometric ratios for standard angles. So 2 minus root 3, as you might remember, correspond to tan of 15 degrees. So tan 15 degrees is equal to 2 minus root 3, and tan of 75 degrees is equal to 2 plus root 3. These are the values which you have already derived. So this is nothing but 2 minus root 3. So case 1, tan theta is equal to tan of 15 degrees is pi by 12. So tan theta is equal to tan pi by 12 implies theta is equal to, what is the general solution for tan theta is equal to tan alpha, n pi plus alpha. So tan theta is equal to tan pi by 12. So you get theta is equal to n pi plus pi by 12. This first case. Or, so 2 plus root 3, 2 minus root 3 corresponds to 15 degrees. The quadrant diagram is this. So you have 15 degrees and pi plus 15 degrees. So these are the two positions correspond to this number. Next, you have tan theta is equal to minus of 2 plus root 3. So we know that 2 plus root 3 corresponds to 75 degrees. I want minus of 2 plus root 3. So obviously, if tan theta is minus, the theta belongs to either fourth or second. You can go to any quadrant. I'll go to fourth quadrant. So the allied position, this is 75 degrees. So allied position will be minus 75 degrees. Minus of 5 pi by 12. That is equal to tan of minus 5 pi by 12. So minus of 2 plus root 3 is the allied angle for 2 plus root 3 in the fourth or second quadrants. I'm taking an angle in the fourth quadrant. So tan theta is equal to tan of minus 5 pi by 12. Hence theta is equal to n pi minus 5 pi by 12. So this is the first answer. This is the second answer. So my answer is either this or this. So theta is equal to n pi plus pi by 12 or n pi minus 5 pi by 12. So these two are the required answers. So now let us look at this question. You're asked to solve secant square theta minus tan theta is equal to 1. So this is a trigonometric equation in more than one trigonometric ratios. You have a secant theta as well as tan theta. So whenever you have equations containing more than one trigonometric ratio, you try your best to convert the equation into a single trigonometric ratio. For example, so you can try to convert tan theta in terms of secant theta or secant square theta in terms of tan theta. So in this particular question, secant square theta can be very easily converted to tan theta using the identity secant square theta minus tan square theta is equal to 1. We have this identity. So secant square theta can be always written as 1 plus tan square theta. So if you write that, so the equation becomes 1 plus tan square theta minus tan theta is equal to 1. This 1 and 1 gets cancelled. So tan square theta minus tan theta, if you take a tan theta as common, tan theta times tan theta minus 1 is equal to 0. So this implies something into something is equal to 0, implies either first term has to be 0 or second term has to be 0. This implies tan theta is equal to 0 or tan theta minus 1 is equal to 0 is equal to tan. Tan theta is equal to 1. So now either this or this, tan theta can be either equal to this or equal to this. So now when will tan theta be equal to 0? So 0 can be written as tan 0. So now this is of the form tan theta is equal to tan alpha. So the general solution is n pi plus alpha. So n pi plus 0, I can leave that. So you get theta is equal to n pi r. So 1 can be written as tan of pi by 4. So theta is equal to n pi plus pi by 4. So these are the two possible solutions, either this or this. So if you are asked to find the principal solutions of this trigonometric equation, so what are the principal solutions of this? Principal solutions are solutions between 0 and 2 pi. So if you take the quadrant diagram, so tan will be equal to 0 at integer multiples of pi. That is 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, so on. So these are the positions of ray which satisfies the first condition, tan theta is equal to 0. Now what are the positions which satisfy tan theta is equal to 1? So tan theta is equal to 1 will be satisfied once in first quadrant, next in third quadrant. So if you go one rotation, what are the values that you get? If n is equal to 0, so you get 0 as one solution, because principal solution has to lie between closed at 0 and open 2 pi. So 0 is one answer. So if you put n is equal to 1, pi is an answer. If you put n is equal to 2 pi is an answer, but 2 pi is not a principal solution because you don't include 2 pi in the principal solution. So this general solution corresponds to two principal solutions, or this solution n is equal to 0 gives you pi by 4, n is equal to 1 gives pi plus pi by 4, that is 5 pi by 4. If you put n is equal to 2, you get an angle which is more than 2 pi. I don't want that. So the principal solutions are 0, pi, pi by 4 and 5 pi by 4. Another variation that can be asked in the same question is, so if this equation has something like 10 solutions in 0, n pi by 2. So if this equation has 10 solutions in the interval 0 to n pi by 2, what is the minimum value of n? Minimum value of n. So if this is asked, this is an interesting question. So if this equation has to have 10 solutions between 0 to n pi by 2, what should be the minimum value of n? So now how do we analyze this? We analyze it using this diagram. So as we have seen, the rays correspond to solution to this equation are this position, this position, this position and this position. These are the four positions that are solutions to this equation. Now you're starting with 0. So you have started from 0, you already got one solution. So you went till 90 degrees, 1 pi by 2, you have two solutions. Next you went till 2 pi by 2, 3 pi by 2, 4 pi by 2. So in one rotation you have 4 solutions. Now if you rotate again 4 pi, so you have rotated through 4 pi and you have got 8 solutions. 0, pi by 4, pi, 5 pi by 4, 2 pi, 2 pi plus pi by 4, 3 pi and 3 pi plus pi by 4, got 8 solutions till 2 revolutions, 4 pi. Now if you go another pi by 2, you get a solution here and a solution here. So you got 2 extra solutions. So you got exactly 10 solutions. So to get 10 solutions, how much revolution should be made? 2 complete revolutions give you 8 solutions, and a quarter rotation gives you 2 solutions in the first quadrant. So you have to rotate through an angle of 0 to how many pi by 2s? 4 times pi by 2s, 8 times pi by 2 plus pi by 2, 9 times pi by 2. So exactly if you go from 0 to 9 pi by 2, you'll have exactly 10 solutions, right? So answer to n has to be equal to 9. So in this video, let us look at how to solve questions having terms sin x plus or minus cos x and sin x cos x. For example, you're given this equation. Sin x plus 6 sin x cos x minus cos x is equal to 1. So how do we solve this? So as you can see in this question, you have sin x minus cos x term, if you group these two terms, and a sin x cos x term. So now what you do in questions having these terms is we take sin x plus or minus cos x is equal to t, depending on the question. So here you have sin x minus cos x. So I take sin x minus cos x is equal to t. So if I do this, what is the simplification that I get? If I square it on both sides, you get sin square x plus cos square x minus 2 sin x cos x is equal to t. Sin square x plus cos square x is equal to 1. So 1 minus 2 sin x cos x is equal to t square. I have squared it on both sides. So I can write 2 sin x cos x is equal to 1 minus t square. So if you do both these substitutions in the given question, sin x minus cos x becomes t plus 6. I take a 3 common in 6. I get 2 sin x cos x is nothing but 1 minus t square is equal to 1. So now this has become a quadratic in t. So t plus 3 minus 3t square is equal to 1. If I send everything onto that side, you get 3t square minus t minus 2 is equal to 0. This can be very easily factorized by putting minus t as minus 3t plus 2t. So if I do that, I get t minus 1 times 3t plus 2. So if you multiply this, you get 3t square minus 3t plus 2t minus 2 is equal to 0. This means either t is equal to 1 or minus 2 by 3. These are the two options that you have. So t can be either equal to 1 or minus 2 by 3. Now we can go for the back substitution. So t means sin x minus cos x. This implies sin x minus cos x is equal to 1 or sin x minus cos x is equal to minus 2 by 3. So now this has been converted to a cos x plus b sin x form. So what do we do in these questions? We divide both sides with root of a square plus b square, right? So if I take, I'll divide this with root 2 on both sides. So this becomes sin x into 1 by root 2 is cos pi by 4 minus cos x into next 1 by root 2 is sin pi by 4. So this can be written as sin of x minus pi by 4 is equal to 1 by root 2 is nothing but sin pi by 4. So this has gone converted into standard question. So x minus pi by 4 is equal to n pi plus minus 1 whole power n times pi by 4. So if we send this pi by 4 onto that side, so you get x is equal to n pi plus minus 1 whole power n times pi by 4 plus pi by 4. This is one part of the solution of this equation. And the second part can be obtained by solving this. So this is slightly tricky because this is not a standard number. So sin x minus cos x is equal to minus 2 by 3. So I divide with root 2 and root 2. This is sin of x minus pi by 4 is equal to. So let us draw a triangle where the opposite side is 2 and the hypotenuse is 3 root 2. And let us call this angle as alpha. Let this angle be alpha, whatever is the angle formed in this triangle. So sin alpha is equal to 2 by 3 root 2. This is minus 2 by 3 root 2. So sin of minus alpha, right? So this implies x minus pi by 4 is equal to n pi plus minus 1 whole power n times minus alpha, that is n plus 1 times alpha, where alpha is an angle whose sine is 2 by 3 root 2. This implies x is equal to n pi plus minus 1 whole power n plus 1 times alpha plus pi by 4. So the solution to this equation is either this or this. So you have solution as a union of these two solutions. So the next type of questions that we encounter are questions based on sum to product type. So what you get in this question is you get the sum of certain trigonometric ratios is equal to 0. So if the sum of three different trigonometric ratios is equal to 0, I cannot really get any conclusions from this. But if the product of these three are equal to 0, I can get some conclusions from that, because if product of three numbers is equal to 0, either for the first one or the second one or the third one has to be equal to 0. So if you have 0 on the right hand side, if you have product here, that will be helpful. But in this question, you're given cos 3x plus cos x minus cos 2x is equal to 0. So what I do is I'll try to convert this sum into product. And how I do is using the transformation formulas. So first, let me do cos c plus cos d. Cos 3x plus cos x. So what is cos c plus cos d? 2 cos c plus d by 2, 3x plus x, 4x by 2 is 2x, into cos of c minus d by 2. 3x minus x is 2x, by 2 is x, minus cos 2x is equal to 0. So this implies you have cos 2x here as well as here. So cos 2x, if I take common, you have 2 cos x minus 1 is equal to 0. So something into something is equal to 0. You have converted sum into product. Now I can draw the conclusions. Either this has to be 0 or this has to be 0. This implies either cos 2x is equal to 0 or 2 cos x minus 1 is equal to 0. This implies cos 2x is equal to 0, corresponds to cos of pi by 2, or cos x is equal to 1 by 2, which is equal to cos pi by 3. So now if cos of something is equal to cos of something, cos 2x is equal to cos pi by 2. So what is the solution? 2x is equal to, correspond to cos, the solution is 2n pi plus or minus pi by 2. So this implies once you have the value of 2x, x will be equal to, if you divide with 2, n pi plus minus pi by 4. Or this is one solution. Otherwise, cos x is equal to cos pi by 3. This implies x is equal to 2n pi plus or minus pi by 3. So you have either this solution or this solution. So if you're asked to find the principal solutions also, you can find them very easily. So correspond to this, the positions that are valid for this is n pi plus or minus pi by 4. That is, if n is equal to 0, you have plus or minus pi by 4. If n is equal to 1, you have pi plus or minus pi by 4. So these are the 4 positions which ensure that cos 2x is equal to 0. Next, correspond to this, you have only 2 positions per revolution. Only 2 positions per revolution. This is pi by 3, 2n pi plus or minus pi by 3. So if I ask you the number of principal solutions, the answer for this question would be 6. So within one rotation, this equation gives me 4 solutions. This equation gives me 2 solutions. So effectively this or this gives me 6 principal solutions. Okay. Now let us go to the next question. This also looks similar to this. So you have sum is equal to 0. So what I do is I'll try to convert this into a product equation. So I'll take sin x and sin 5x. What is sin c plus sin d? 2 sin c plus d by 2, x plus 5x is 6x, by 2 is 3x, into cos of c minus d by 2, x minus 5x is x. Sin c plus sin d is 2 sin c plus d by 2 cos c minus d by 2, x minus 5x is minus 4x, by 2 is minus 2x. But inside cos, plus minus doesn't matter. So plus sin 3x is equal to 0. So I take sin 3x as common, times 2 cos 2x plus 1 is equal to 0. So sin 3x is equal to 0, or cos 2x is equal to minus 1 by 2. So sin 3x is equal to 0. 0 can be written as sin 0. So 3x is equal to n pi plus minus 1 whole power n into 0. 0 can be neglected. So you have n pi. Implies x is equal to n pi by 3. Or minus half corresponds to cos of. So if you take the quadrant diagram for cos, plus plus minus minus. So if cos x is negative, you get an angle in the second quadrant. So correspond to half, the allied position is pi by 3, 60 degrees. So the allied position in the second quadrant is pi minus pi by 3 is 2 pi by 3. So this can be written as cos of 2 pi by 3. So 2x is equal to 2n pi plus or minus 2 pi by 3. So x is equal to n pi plus or minus pi by 3. N pi plus or minus pi by 3. So either this or this is the valid solution. So if you are asked to find the number of principal solutions, so how we do is, if you take the first case, so the positions which satisfy this equation are n pi by 3, that is n is equal to 0 gives you 0, n is equal to 1 gives you pi by 3, n is equal to 2 gives you 2 pi by 3, 3 pi by 3 is pi, 4 pi by 3 is 240 degrees, 5 pi by 3 is 300 degrees, and 6 pi by 3 is again 2 pi. So in one rotation you have 1, 2, 3, 4, 5, 6 solutions. So this has 6 principal solutions. Next, if you go for this, n pi plus or minus pi by 3, that is, if n is equal to 0, you have this position and this position. If that is pi by 3 position and minus pi by 3 position. If n is equal to 1, n pi plus or minus pi by 3 is pi minus pi by 3 or pi plus pi by 3. This is something like 120 degrees position, this is minus 120 degrees position. So these are the 4 positions which satisfy this equation. So sin 3x is equal to 0 is satisfied by 6 solutions. This has 4 solutions. So the total number of principal solutions, if you write that as 10, that will be wrong, because as you see, the solutions of this are also solutions of this. Pi by 3 is there here and here, so you cannot count it 2 times. 2 pi by 3 is repeating, 4 pi by 3 is repeating, 5 pi by 3 is repeating. So all the principal solutions of this equation are solutions to this equation also. Hence you have only 6 principal solutions to this equation also. And those are 0, pi by 3, 2 pi by 3, 3 pi by 3, 4 pi by 3 and 5 pi by 3. So in this video, let us look at some important points to remember while you're solving trigonometric equations. The first point is that a trigonometric equation can be solved in different methods. So there is no single way to solve a trigonometric equation. It can be solved in different methods, and in different methods you might get different forms of general solutions. So different general solutions. So the answers that you obtain and your friend obtains might be looking different. There's no problem, both of them might be right. So if you want to check the validity of 2 solutions, you should not see just the general solution form. So what you need to do is you expand them into roster form and see whether you're getting the same solutions or not. So different general solutions get same roster form on expansion. So if all the solutions get the same roster form on expansion, all of them are right. So the second thing that you need to remember is avoid cancellation of trigonometric ratios. So avoid cancellation to avoid losing roots. So if you cancel trigonometric ratios in a trigonometric equation, you might lose some solutions. For example, let us say that sine theta is equal to tan theta. This is the trigonometric equation that you're given. What is the solution for this? So what you should not do is sine theta is equal to sine theta by cos theta. So I'll cancel this cos sine theta out. This implies 1 is equal to 1 by cos theta. This implies cos theta is equal to 1. And this implies theta is equal to, for what values cos theta will be equal to 1? 2 and pi. Even multiples of pi, cos theta is equal to 1. So if you solve this in this way, the process might look right, but the answer that you get is not completely right. So what is the mistake in this process? If you cancel the sine theta out, you're losing some roots. So the right way to do this is sine theta is equal to sine theta by cos theta. This implies, so if you bring both of them onto one side, sine theta minus sine theta by cos theta is equal to 1. Take sine theta as common. Sine theta times 1 minus 1 by cos theta is equal to 1. Sorry, is equal to 0. Right? If you bring this onto this side, you get 0 here. This implies either sine theta is equal to 0 or cos theta is equal to 1. This implies theta is equal to n pi or theta is equal to 2m pi. So it can be just a multiple of pi or an even multiple of pi. Or means union. So you have to combine these two solutions. Obviously this solution is a subset of this solution. Hence if you do union of these two, you get this as the answer. The actual answer is any multiple of pi. So if you cancel this sine theta out, you got the answer as only even multiples of pi. You have lost some roots. So whenever you do cancellations, there is a chance of losing some roots. So avoid cancellation in trigonometric equations. So if you want to cancel them, bring them onto one side and take that as common. Otherwise, if you want to cancel it out, whenever you cancel numerator, so if you have numerator by denominator is equal to some numerator by some denominator in trigonometric equations, if you cancel the numerator, you have to write numerator is equal to 0 as one of the solution. Numerator is equal to 0 or this. And if you cancel the denominator also should be very carefully cancelled. If you cancel the denominator, you have to write denominator not equal to 0, because you can cancel denominator only if the denominator is not equal to 0. So whenever you cancel a factor in the numerator, write that factor is equal to 0 as an extra solution. That means whenever I do this, I write this or sine theta is equal to 0. That means 1 by cos theta is equal to 1 or sine theta is equal to 0. This is one way in which you can avoid your losing of roots. The other method is don't cancel, just bring everything onto one side and take the common factor as the common factor. So the thing that you need to understand is if you cancel out the numerator, write numerator is equal to 0. And if you cancel the denominator, you have to write the denominator should not be equal to 0. Okay, so now let's go to the third point. The third point is avoid squaring. Avoid squaring because squaring might lead to extra solutions. Avoid squaring, that means because squaring might lead to extra solutions. So for example, if you have sine theta is equal to 1, so you know that the answer is 4n plus 1 times pi by 2. But if you avoid writing the solution at this stage, we square it on both sides. Sine square theta is equal to 1 after squaring. So what is the solution for this equation? Theta is equal to n pi plus or minus pi by 2. So as you can see, this solution is different from this solution. This has only one principal solution. This has only one position of the ray. This solution has two positions of the ray. Obviously, you have got some extra solutions. So whenever you square it, you have the danger of getting an extra solution or extra solutions. So what you need to do is, sometimes you will need to square in an equation. If you have some square roots, you'll be needing to square it. But whenever you square the equations, make sure that once you get the final answer, you check the solutions with the original equation. Some of the solutions might not satisfy the original equation, just remove them. So that's what you do when you'll need to square the equation on both sides. The third point says that avoid squaring as much as possible, but if it is necessary to square it. But once you get the final solution, make sure that you check all the solutions. So the next point is, once you get the solutions in a trigonometric equation, it's always a good practice to check the solutions whether they're satisfying the original equation or not. So verify the solutions, because sometimes the solution which you get finally might not satisfy the original equation. For example, if the original equation have certain extra functions like log function. So if you have sine theta inside log is equal to 1. So we usually convert this into exponential form and solve the equation. And finally, if you have the solution as theta is equal to 4n minus 1 times pi by 2. Suppose you got the solution after doing some number of steps. So as you can very clearly see, when theta is equal to 4n minus 1 times pi by 2, sine theta is equal to minus 1. So log is not defined at this solution. Hence, I write that this solution is not valid. So whenever you have some extra functions which have certain restrictions on their domain, so once you get the final solution, you should check whether the solutions satisfy the given equation or not. So that's a good practice. So you need to keep all this in mind while solving trigonometric equations. So in this question, you're asked to solve sine square theta is greater than cos square theta. So one of the method is you can draw the graphs of sine square theta and cos square theta, and you can see where sine square theta is more than cos square theta. And the other method is you just bring cos square theta onto the denominator. So sine square theta by cos square theta is greater than 1. So assuming that cos square theta is not equal to 0. As long as cos square theta is not equal to 0, I can divide both sides by cos square theta, and you get sine square theta by cos square theta is greater than 1. This implies tan square theta is greater than 1. Now, this is a trigonometric inequality in tan square. So what we do is we try to solve this inequality in one interval, one period of tan square theta, and then we'll extend it to the other periods. And the period of tan square theta is nothing but pi. So the graph of tan square theta minus pi by 2 to pi by 2. So the value goes to infinities at these two values. So tan square theta starts from 0 and goes to infinity at x is equal to pi by 2. Because it is square, it also goes to plus infinity on this side. Actual tan will go to the negative side, but if you square it, it goes to plus infinity. Now draw the line y is equal to 1. So draw the line y is equal to 1. So now this line intersects obviously this curve at 2 points. So let us say that this is x1, this is x2. Now x1 and x2 are 2 points which are the intersections of y is equal to 1 and y is equal to tan square theta. So these x1 and x2 satisfy the condition tan square of x is equal to 1. Because this is the point of intersection of these two curves. That means correspond to x2. 1 has to be equal to tan square theta or tan square x. This implies tan x is equal to plus or minus 1. So x is equal to either plus pi by 4 in the first quadrant or minus pi by 4 in the fourth quadrant. So this number is plus pi by 4, this number is minus pi by 4. So these are the 2 points of intersections. Now I want my tan square theta to be greater than 1. I want my tan square theta to be greater than 1. That means I want my graph to be above this line. So what is the answer? X belongs to pi by 4 to pi by 2. So x can belong to pi by 4 to pi by 2 or minus pi by 2 to minus pi by 4. Minus pi by 2 to minus pi by 4. This is the solution in one interval minus pi by 2 to plus pi by 2. So if you want the complete answer, you just need to add n times period to these extremities. So the general answer is x belongs to n pi plus pi by 4 to n pi plus pi by 2 or n pi minus pi by 2 to n pi minus pi by 4. So this will be the required answer where n belongs to integers. So now that you have learned the topics of trigonometric equations, so let us move on to our next topic, trigonometric inequations. So now, what are trigonometric inequations? These are nothing but trigonometric equations where equality is replaced by the symbols greater than or equal to, less than or equal to, greater than or less than. So if you use some of these symbols, then we call the equation as an inequation. For example, let us take a very simple trigonometric inequation. Sin x is something like greater than or equal to half. We're asked to solve this. So in trigonometric inequations, while solving them, we use a beautiful property of trigonometric functions, which is called the property of periodicity. So we know that trigonometric functions repeat after certain amount of interval. That is, if you take sin x, if you take the graph of sin x, so we know that the graph of sin x looks like a wave, right? Looks like a wave, and the numbers, if you write 0, pi, 2 pi, 3 pi, minus pi, minus 2 pi, so on. So this graph goes on like a wave, and if you take this part of the wave, the part of the wave between 0 to 2 pi, you can consider this as a basic wave, and you can think of this wave getting repeated again and again. So the same numbers are repeating again and again. So the period of sin x is said to be 2 pi. The interval after which the values of a function repeat themselves is called the period of the function. So sin x's period is 2 pi. That is, sine of x plus 2 pi will be again equal to sin x. That is, if you take any value x, if you increase the value of x by 2 pi, you get the same functional value. It is the value of sin x repeats after an interval of 2 pi, right? So 2 pi is the period of sin x. In this way, all trigonometric functions repeat after certain intervals. Interestingly, if 2 pi is a period of sin x, I can also say 4 pi as a period of sin x. Because if I take this as a basic cycle, this cycle repeats itself. I can say that this has a basic cycle. So this cycle is also repeating itself. Hence, if 2 pi is a period, all multiples of 2 pi are also periods. And the least of all these periods is called the fundamental period. The least period is called the fundamental period. So for sin x, the fundamental period is 2 pi. I cannot go less than 2 pi, because if I go till pi, this graph is not repeating itself. So the basic cycle is a cycle of length 2 pi. I don't need to take exactly this part of the cycle. I can also take this part of the cycle. So I can say that this part of the cycle is also repeating itself. So any continuous interval of 2 pi, so if you take for sin x, we can think of it as repeating itself. Hence 2 pi is the fundamental period of sin x. So in this way, different trigonometric functions have different fundamental periods. So I'll write the periods. So sin x, the period is 2 pi. Cos x, the period is also equal to 2 pi. And if sin x repeats after 2 pi, cosecant x also repeats after 2 pi. Secant x should also repeat after 2 pi, right? But for tan x and cot x, the fundamental period is pi. So you can go to the graphs and look for the fundamental period. What is the interval of tan x which you need to take such that the graph repeats itself? So the graph of tan x repeats itself after every pi units. That is, tan of x plus pi will be equal to tan x. So if pi is a period, 2 pi is obviously a period, but pi is the fundamental period. But for sine, cos, cosecant and secant, 2 pi is the fundamental period. So we use this property of periodicity to solve trigonometric inequations. So let us see how we do this. For example, let us take the inequality sin x greater than or equal to half. So how do we solve this inequality? So the process is, so first step, I draw the graph of sin x. Draw the graph of y is equal to sin x. If sin x is given, draw the graph of sin x, cos x, tan x, whatever is asked, first draw the graph of the given function. Next, identify the points where the equality holds. That is, first identify the points where sin x is equal to half. So forget about the inequality in the starting. Just draw the line y is equal to half. That is, y is equal to what our number is given. That means sin x is equal to half. That means y is equal to half. So if you take half lies somewhere here. So you draw a horizontal line corresponding to y is equal to half. Now, try to solve the inequality in one complete cycle. That is, a length equal to the fundamental period of whatever function is being considered. For sin x, we know that the fundamental period is 2 pi. So take some interval of length 2 pi. For example, let us take 0 to 2 pi. This is 0, this is pi by 2, this is pi, this is 2 pi. So solve the inequality in this interval. So we know that sin x is equal to half. This value is pi by 6, 30 degrees, and this value is 5 pi by 6, 150 degrees. Pi by 6 and 5 pi by 6. Now, I want my value of sin x to be greater than or equal to half. So I want the graph to be above the vertical line. That is, this horizontal line represents y is equal to half. That means all the points on this line satisfy the condition sin x is equal to half. Now I want sin x to be greater than or equal to half. That means I want the interval where the graph of sin x is above this line. That is the interval pi by 6 to 5 pi by 6. And this is the solution of this inequation in one cycle. Because in the next cycle I am getting another interval. In the previous cycle I get another interval. In the next cycle I'll get another interval. So I'll go on getting intervals in each cycle. So in one cycle, if I solve this inequality, the value is x belongs to closed pi by 6, because you have an equality here, to 5 pi by 6. So this is the solution in one cycle. Now what is the solution in the next cycle? Obviously, if sin x is equal to half at pi by 6, due to periodicity, it will be equal to half at exactly this point at a distance of 2 pi from this. And 5 pi by 6 corresponds to this point moved at a spacing of 2 pi. Similarly, this point corresponds to this moving back at distance of 2 pi. This point corresponds to this point moving back by 2 pi units. And if you want to go to the next cycle, you need to add again one more 2 pi. That means effectively you're going 4 pi units forward. This is also going 4 pi units forward. Next step, 6 pi units forward, 6 pi units forward. That means you go some number of times the fundamental period. So graph of sin x, draw the horizontal line, solve in one cycle, you get the solution, and just add n times t to both the limits, both the extremities. That's the final solution. That means the final solution will be x belongs to 2 pi times n. N times the period of sin x is 2 pi. So 2 pi times n plus pi by 6 to 2 pi times n plus 5 pi by 6. So this will be the answer to this question. So if you put n is equal to 0, you get the interval pi by 6 to 5 pi by 6. If you put n is equal to 1, you get the next interval, 2 pi plus 5 by 6 to 2 pi plus 5 pi by 6. If you put n is equal to 2, you get the next interval. N is equal to 3, next interval, so on. And if you put n is equal to minus 1, you get this interval. So, and this goes on. And here n belongs to integers z. So this will be the final solution to this inequality. And whatever inequality is given, we follow the same process. First, we draw the graph. We draw a horizontal line corresponding to y is equal to number given here. Next, we solve the inequation in one interval, and then we add n times t to both the extremities. So once you do that, the solution for the inequality is complete. Now let us look at this inequality. You're asked 2 cos square theta plus sin theta is less than or equal to 2. You're asked to solve this in this interval pi by 2 to 3 pi by 2. So this is not a very easy inequality like we have seen in the previous example. So this has both cos square and sin. So the first thing that we try to do is we try to convert this inequation completely into one trigonometric ratio. So you can try to convert cos square into sin square or sin into cos. The better way is to convert cos into sin, because if you convert sin into cos you get a square root unnecessarily. So 2 times cos square is 1 minus sin square theta plus sin theta is less than or equal to 2. So 2 minus 2 sin square theta plus sin theta is less than or equal to 2. This 2 and this 2 gets cancelled. So if you carry over everything onto that side, 2 sin square theta minus sin theta is greater than or equal to 0. This implies sin theta times 2 sin theta minus 1 is greater than or equal to 0. Sin theta times 2 sin theta minus 1 is greater than or equal to 0. This implies, so the product of two numbers have to be positive. So if the product of two numbers is positive, then the condition is either both of them can be positive or both of them can be negative. So sin theta greater than or equal to 0 and 2 sin theta minus 1 greater than or equal to 0, or either both these can happen, or sin theta less than or equal to 0 and 2 sin theta minus 1 is also less than or equal to 0. So if you take this case, sin theta has to be positive and sin theta has to be greater than or equal to half. So what is the common solution to this? It has to be positive and greater than half. That means the common solution is sin theta is greater than or equal to half. And sin theta less than or equal to 0 and sin theta has to be less than or equal to half. So sin theta is less than 0 and less than half. What is the common solution for this? Sin theta is less than or equal to 0, right? So if this is less than 0, it will automatically be less than or equal to half. If it is greater than or equal to half, it will automatically be equal to greater than or equal to 0. So the solution is either sin theta less than or equal to 0 or sin theta greater than or equal to half. So what we do is we try to solve these two inequalities. First, we draw the graph of y is equal to sin theta from 0 to 2 pi. That's sufficient. I don't need to draw a complete graph. Let me draw one cycle 0 to 2 pi. So if you want to solve this inequality, first draw the line y is equal to half. So y is equal to half. So it cuts the graph at 2 points. It means at these 2 points, the value of sine is equal to half. This is pi by 6. This is 5 pi by 6. So in between these two, as you can see, I want sin theta greater than or equal to half. It means I want the graph to be above this. So the answer to this is, in the first cycle, is sin theta belongs to closed pi by 6 to 5 pi by 6. And for the second one, sin theta is less than or equal to 0. Sin theta is less than or equal to 0. So where is sin theta less than or equal to 0? So just draw y is equal to 0 this time. I want my graph to be below this, y is equal to 0. That means this part. So union, either this or this is nothing but pi to 2 pi. So if theta, this is the value of theta. So if theta belongs to pi by 6 to 5 pi by 6, both of them will be positive. Both these quantities is positive and effectively is greater than or equal to 0. If theta belongs to pi to 2 pi, both of these will be negative, hence the product will be positive. So the solution is either this or this. So I want the solution between pi by 2 to 3 pi by 2. That means I want the solution from pi by 2 to 3 pi by 2. So what is the solution between this? So I can have a solution like pi by 2 to 5 pi by 6. The required solution is pi by 2 to 5 pi by 6 or pi to 3 pi by 2. So both of these are valid solutions. If you want the general solution, if you want the complete solution, what you just need to do is, for this 2n pi plus pi by 6 to 2n pi plus 5 pi by 6 union 2n pi plus pi to 2n pi plus 2 pi. So this will be the combined solution, combined general solution to this inequation. And if you want the solution between pi by 2 to 3 pi by 2, this will be the answer. Thank you.